Arise, awake, and stop not till the goal is reached. Warm good morning, everyone. I welcome you all to the 5-day workshop on machine learning for data science and analytics. Let's start today's program with prayer.
Om Shri Gurubhyo Namaha Harihi Om Sahanavavatu Sahanau Bhunaktu Sahaviryam Karavahai Tejasvinavadhitamastu ma vidvishavahai. Om Shanti Shanti Shanti. Om Purnamadah Purnamidam Purnat Purnamudachyate Purnasya Purnamadaya Purnamevavashishyate. Om Shanti Shanti Shanti. Hari Om Tat Sat. Shri Ramakrishna Arpanamastu.
We want that education by which character is formed, strength of mind is increased, the intellect is expanded, and by which one can stand on one's own feet. Swami Vivekananda. Now, I request Dr. R. Sridhar, coordinator of 5-day workshop on machine learning for data science and analytics, to deliver welcome address.
Good morning to all. Welcome to 5-day workshop on machine learning for data science and analytics, sponsored by AICTE-ATAL for Ramakrishna Mission, Vivekananda Educational and Research Institute. My respectful pranams to Swami Garishananda Maharaj, Secretary of Ramakrishna Mission Vidyalaya, which is having more than 17 institutions spread over 300 acres of land at Coimbatore. My hearty welcome to professors, associate professors, assistant professors of different institutions and industrial participants, and there are nearly about 70 institutions of 19 states are participating in this program. We hope that we'll get benefited out of it. Swami Vivekananda said, if the poor cannot come to the education, education must reach them at the plow, in the factory, everywhere. We are able to see the vision of Swami Vivekananda come true, where people could be educated at their own places with no cost, irrespective of caste, gender, greed, and so on. Ramakrishna Mission Vidyalaya, Coimbatore is a well-known educational center of Ramakrishna Mission, Belur Math, Aura, West Bengal, serving the people for the last 89 years. Foundation stone was laid by Mahatma Gandhi in the year 1930. A serene environment campus of 300 acres consists of 4 schools, 4 technical institutions, 4 higher education institutions, and 4 faculty of Ramakrishna Mission Vivekananda Educational Research Institute, catering to the educational needs of 7,000 students every year. Ramakrishna Mission Vivekananda Educational Research Institute is deemed to be institute as declared by Ministry of Human Resource Development, Government of India in the year 2005. It is being administered and run by Ramakrishna Mission. At present, it operates through 4 campuses situated at the different locations: Belur Math near Kolkata, Coimbatore, Narendrapur, and Ranchi. The university houses many departments covering a diverse range of subjects such as physics, mathematics, computer science, yoga, Sanskrit studies, rural and tribal department, agriculture, disability management, adapted sports, disaster management. Programs are conducted at various levels ranging from undergraduate, diploma to doctoral levels. Following 4 faculties of RKMVERI situated within the premises of Ramakrishna Mission Vidyalaya are Faculty of Disability Management and Special Education aims at preparing teachers in special education and train persons with disabilities to equip them with daily living, academic and vocational skills. Faculty of General Adapted Physical Education and Yoga focus on physical educational needs of persons with disabilities and prepares adapted physical educators and yoga trainers. Faculty of Agriculture Education and Research provides quality agriculture education that caters to the needs of agriculture and rural development in terms of supporting employment, ancillary business, and environmental studies. Faculty of Computer Science Application and Research, recently we have renamed it as Department of Computer Science and the School of Mathematical Sciences, conducts an integrated MSc program and MSc Data Science. It is all related completely with the industry models where the newer skills, recent trends, and cutting-edge technologies will be taught throughout the tenure or throughout the academic period year. To meet demands of recent trends in the industries, we update our curriculum and self-development activities. In this workshop, 5-day workshop, there will be 14 sessions as scheduled. Here, 1 or 2 speakers may be changed according to the needs because of the unavoidable circumstances they are not able to participate. One is Dr. T.E. Venkatabalaji, who is from IIT Madras, who is about to give a lecture on mathematics and data science related to algebraic geometry, will be absent today because of his sudden demise of his brother yesterday night. And today's session will be followed by Sandhya, who is a co-founder of Patchlet Lab, where she'll be taking a 9 to 11 and 11 to 12:30 session, whereas she'll be covering on Introduction to Python for Data Science, and followed by A. Sendil Kumar, Statistics in Data Science. So with these few words, I feel pleasure to welcome you all for this 5-day workshop. We hope that you will be getting benefited, and we'll be sending you the feedback after every day. Please fill up the feedback and we'll be able to update our way of teaching methodology or way of any kind of an educational approach for the improvement of this workshop. So we welcome you all for this workshop. We hope that you'll get benefited. Once again, my sincere pranam to Vivekananda Maharaj, who is with us to give an inaugural address at this moment. So thank you all for participating in this event.
Thank you very much, Dr. Sridhar sir. Now, I wish to welcome the most respected Swami Garishthananda Ji Maharaj, Secretary, Ramakrishna Mission Vidyalaya, Coimbatore, to deliver inaugural address on digital revolution. We request you, Maharaj.
My namaskars and loving greetings from Ramakrishna Mission Vidyalaya, Coimbatore, Tamil Nadu, to all the participants of this workshop. In my inaugural address, I would like to say some words about digital revolution. Before that, I'd like to brief you all about this institution. This Ramakrishna Mission Vidyalaya, Coimbatore is a major educational complex spread over nearly 275 acres, and it is a branch center of the worldwide Ramakrishna Mission, Howrah, West Bengal. The Ramakrishna Mission was founded by Swami Vivekananda in his Guru's name, Sri Ramakrishna Paramahamsa, at Kolkata, West Bengal. At present, there are 218 branch centers under Ramakrishna Mission. In our country, 164, and abroad, 54. This mission center at Coimbatore was founded in 1930 by Dr. T.S. Avinash Lingam, a freedom fighter and also the first education minister of then Madras Presidency. Mahatma Gandhi laid the foundation stone of this institution in 1934, and in 1935 it is affiliated to the Ramakrishna Mission, Belurmet, West Bengal. As said by Dr. Sridhar in his welcome address, here we have 3 schools, 3 technical post-matric institutions, and in higher education, we have College of Arts and Science, College of Education, Physical Education College, Faculty of Disability Management and Special Education, Faculty of General and Adapted Physical Education and Yoga, Faculty Center for Agricultural Education, and Faculty Center for Computer Science Applications. Under the Faculty Center for Computer Science Applications of Ramakrishna Mission Vivekananda Educational and Research Institute, a deemed university, this workshop is being organized. The history of human civilization has passed through milestones such as prehistoric Stone Age, Bronze Age, Iron Age, and so on. Each one of them is marked with certain middle inventions for the betterment of human living. After years of nomadic culture, there was agricultural revolution where civilization started settling down into settlements. Then came the Industrial Revolution. Industrial Revolution took place in 3 stages. The first one is from 1760 to 1860, roughly 100 years, and it started in Europe. The main focus was the invention and utilization of the steam powers, mechanization of various manufacturing sectors, and so on. The second one is between 1870 to 1920, after Maxwell came up with the theory of electromagnetism, which led to the generation of electricity. Electricity was a milestone that changed the lifestyle of all human beings. Then came communication, that is telegraph and telephone. In communication earlier, we had analog devices in which continuous signals were processed. Then the advancement of semiconductor technology ushered us from mechanical devices and analog electronics to digital solid-state device technology in 1950s. For nearly 20 years, the scale of integrating large portions of circuits in smaller and smaller dimensions and building more and more powerful digital computers with these smaller transistors or electronic switches kept on increasing. So we had small scale and medium scale integration in 1970s, and by 1980s, we had very large scale integration of electronic circuits, that is, process of creating an integrated circuit by combining millions of MOS transistors into a single chip. Then from 1980s, we had personal computers. At the same time, the notion of computer networks emerged. As the hardware technology started progressing, in 1990s, we had the World Wide Net, which was an extension of the computer networks. Although the internet started mainly in the developed countries, by 2000, it spread all over the developing world and also in other domains such as digital signal processing for voice, audio, images, videos, and TV signals. Globally, the number of internet users increased from 413 million in 2000 to over 3.4 billion in 2016. There are 5.15 billion mobile phone users in the world today, according to the latest data from Global System for Mobile Communications Intelligence. We also have tablets, smartphones, driverless automobile cars, robots, 3D printing, and whatnot. Under the sky is a limit for imagination. All these are possible because of an excellent synergy between computing power and telecommunication idea. It is based on hardware technology and software algorithms. It is often called as information and communication technology, ICT. Digital revolution plays an important role in education. Now all the famous lectures in the renowned universities are available on internet. Thus, the students can get these lectures along with the videos of the pioneers in the specific fields. This is even available to students in school level also. The school students in their biology practical class need not dissect a real frog to know about the frog system. Instead, they can learn everything from the computer image. Today, travel from one place to another place anywhere in the world has become much easier. Previously, we had to ask people for a route unknown to us. Now, with the help of the road map and GPS, we are able to get the details of the route in advance. We don't have to stand in long queues anymore in front of the railway reservation counters. We buy train tickets online along with confirmed reservation. And the same is the case with the air ticket reservations also. Healthcare is another benefit of digital revolution. Sometimes we find people wearing something like a watch that shows the distance we have covered, the total time we have slept, our heartbeat, our blood pressure, etc. Further, research is already going on to find ways of measuring blood sugar without drawing blood from the body. Scientists are also working so that the health-related information can be directly conveyed to the concerned doctor. Digital revolution has given us smartphone appliances. For example, TV. TV remote is already in use for quite a long time, but now we can give voice command for any particular type of program, and even gesture can also be used to give command. Then comes smart door locks, smart refrigerators. These are needed keeping in mind the problems of the aged people who are very sick and cannot even get up from the bed. Everything in this creation has two sides, the dark and brightness. So far, we are seeing the brighter side of digital technology when utilized properly. The darker side of digital technology is to become slaves of our inventions. This is harmful not only for an individual, but also for the entire society. We should not remain so engrossed with our smartphone or any other devices that we become isolated and forget the rest of the world. If this technology continues to dominate our lifestyle, then nomophobia, that is, no mobile phone phobia, could be the next epidemic that may affect us. This nomophobia is defined as the fear of being out of mobile phone contact. It is an anxiety disorder. In addition to the mind, it affects relationship where a person is psychologically absent despite being physically present. Another point of concern is the disposal of the integrated circuits after use. The integrated circuits are made up of not only silicon from sand, but also of many other materials which are toxic in nature. These integrated circuits have a specific lifespan, so on repeated use for a prolonged period, say for 10 or 15 years, they lose the efficiency and are to be disposed. But this practice is harmful to our Mother Earth. Hence, we need to develop eco-friendly technological products. Another main demerit of digitalization is cybercrime. As per the information reported to and tracked by the Indian Computer Emergency Response Team, the number of cybersecurity related incidents are increasing gradually. Sri Ramakrishna Paramahamsa says in one of his parables, a knife can be used to cut vegetables and fruits, which will satiate a human hungry man. It can also injure a person if it is used indiscriminately. Similarly, let us all use the digital technology for the benefit of the entire humanity. I am happy to hear that today nearly 200 teachers and research scholars from 19 states are attending this workshop, Mission Learning for Data Science and Analytics through online, which stands as a good example for digital revolution. Hope all of you will get benefited by the workshop, since experts will be sharing their domain knowledge with you all through online. I once again convey my good wishes to all the participants of the workshop. Thank you very much.
I thank Swamiji for his detailed explanation about origin and evolution of technology on the topic digital revolution. Thank you, Maharaj. Now, I request Dr. R. Sridhar to introduce speakers of today's program. Request you, sir.
So once again, we welcome all the participants. The participants enrollment was around 220, but we have been sending a Google form for confirming the registration. So till yesterday, it was around 196 participation enrolled for this. But this inaugural session, we are able to see that there are about 73 participants who have been present here. So 75, we hope that remaining participants will be participating it faster. And today's first and second session will be taken by Sandhya, who was a co-founder and a director of Paslet Image Labs Private Limited. She won a Best Innovation Award at Indian Plant Science Congress in 2019, hosted by SRM Institute of Science and Technology for designing a device that detects a leaf disease in plants. One among 40 startups in BIRAP, Social Alpha Quest for Assistive Technology, supported by Emphasis, hosted by Tata Trust 2019. Best Startup Award in SATI under AICTE at Indian International Science Festival Lucknow in 2018. One among top 3 startups, among 300 plus established startups in Swadeshi Startup, Smith, hosted by Unnat Bharat Abhiyan at IIT Delhi in 2018. She secured 44th rank among 5,000 ranked holders of Bachelor of Engineering on Electrical and Electronics. She is exhibitor of our design, which you have been doing it related to the blind people in Kannada Indian Women Accelerator Program hosted by AICTE in 2019. She won second prize at state level engineering design conducted by TAFE in 2016 for developing a smart key for visually impaired with obstacle avoidance system. And first prize she scored in Yantra, a national level engineering design contest organized by National Instrument 2016 with a cash prize of 75,000. We welcome her for being a speaker with us as for the first and the second session, where she'll be concentrating on introduction to Python for data science. We welcome her. And Suresh Shah, who is also going to be the participant along with Sandhya, Dr. J. Suresh, who is working as an assistant professor in electronics and communication engineering in Banariaman Institute of Technology. And apart from that, he is a co-founder of Paslet Image Lab. He has published more than 12 articles in reputed journals, delivered a lecture and handled sessions in more than 5 workshops. He has won a Young Scientist Award, Indian Plant Science Congress 2019 by SRM Institute of Technology for his research work on performance analysis of hyperparameter in convolutional neural networks for grape disease classification. And Indian Best Innovation Award, Indian Plant Science Congress 2019 for the device that detects a leaf disease in plants. One among top 40 startups in BIRAC, Social Alpha Quest for Assistive Technology, supported by Emphasis, hosted by Tata Trust 2019. Best Startup Award in SATI at the Indian International Science Festival, Lucknow. And one among 3 startups among 300 plus established startups in Swadeshi Startup Smith, organized by Unnat Bharat Abhiyan at IIT Delhi in 2018. He is also participated in as an exhibitor in Canada Indian Women Accelerated Program hosted by AICTE in 2019. So we welcome Suresh, Dr. G. Suresh and Sandhya for these two sessions where they will be talking about introduction to Python for data science, where some mathematical part also will be introduced. So we request Sandhya to start taking up the classes or lecture series.
Good morning, everyone. Thank you, Sridhar sir, for the kind gesture. So, myself, Sandhya, I'm the co-founder of Paraclet. At Paraclet, we develop assistive devices for visually impaired people. We work on range of deep learning-based solutions that help blind people live their life independently and self-reliantly. Our first product is Prakash. It's a reading solution that enables blind people read printed content directly without the help of scribes or braille books. So today's session, just a quick check. So is my screen visible? There should be a slide pointing as a sneak peek into data science. So I just want a confirmation. Is the screen visible?
Yes, please, you can. Yes, please, your screen is visible.
Yes. So today's session in the morning, we'll be dealing about, it's a combination of both the mathematics as well as the basic Python that's required for data science. So we as individuals are very familiar with the different programming languages that we are that we have been studying, say starting from our school days till the lot of undergraduation courses on. So here, why is Python and why is Python specifically for data science? So we'll just have a quick look at what data science has and what and all are the different cycles the data transforms during the process in implementing real time while implementing it onto real time solution, followed by what is the role of a data science, what are the different positions a data scientist hold in a data based company, and after this we'll just have a quick look at what Jupyter notebook is, and we'll be starting hands-on session. So in this particular slides or in this particular PPT, what we'll have a quick look at is three basic things. So why is data science, specifically why data science now, and what is data science, and how Python is used for data science. So coming to the need of data science, like every one of us have smartphone in our home, and we are all engaged with n number of devices that gather data of us, knowingly or unknowingly. We are contributing to the huge corpus of data that's been gathered from every individual. So in the previous olden days, it was not the case. Like hardly we had a phone in each home, and the kind of data that was collected at that time was very less. So if you can look onto the first part, which says then previously we had structured data. So whereas the data that we got was very structured. Say it was like from a machinery that was being run, it was from the sensors that were there onto the particular industry. And even when, let's consider phone calls, it was the phone calls that were there in the previous day was very structured, where the communication was duplex or monoplex. So it was very structured, and the data that we were passing and we were receiving was very counted. But whereas the data that we have is completely unstructured, even when we are browsing a website, right? So every click of us gets loaded as the data. When we are using Google Maps to get our way to the unknown places, every point that we move becomes our data. And because of this huge collection of data, most of them go unstructured. Like every minute there are millions of videos getting onto YouTube, and we don't know what are the contents that basically present in every YouTube video. We don't know whether it's educational, whether it's media, whether it's music. So all these contribute to huge amount of unstructured data. Next, coming to the previous olden days, the data, there was a data warehouse which was very constrained, and we were very calculated about how much data was getting generated, and we had very organized way of handling the data. But whereas nowadays the Hadoop has come into picture to help us handle this huge corpus of data. And previously, these were the data that we obtained. Let's consider an industrial machine. The data that we were using and we were using that data for kind of traditional business analytics, right? We just get data of what was the sale that happened for the last year, let us say in a garment shop, in some supermarket, what was the sale that happened the previous year, and what is the forecast in the coming year. Or in terms of industrial data, what was the data that we had, the sensors data or the machinery data the previous day, and what is the data that we're having today. And all these data was used for getting useful information in a very traditional manner. The kind of business or the kind of financial returns that were obtained from the data was very less. But whereas what we are using today is we use n number of very advanced data science algorithms to get a huge amount of useful insights that is helpful for us in boosting our financial, as well as getting a high increased profit share. And last, there was only a predetermined, the report was a very of predetermined manner. Like we just forecast, say this was the price of the stock market tomorrow. But whereas here we are able to predict the price of stock market in an even advanced manner with a lot of scientific discovery. So with all this, we are able to identify that in the olden days, with the less penetration of edge computing devices, the data that we got was very less. It was very structured, and the kind of insights that we were obtaining was very limited and in a very traditional manner. But rather now, with a high amount of edge computing devices and large quantity of data being generated through every edge computing device, there's a need for a science that has to be put into data. So it's basically a science that we are going to put onto data. And what are we doing? So to handle and analyze extremely large data flow in data science, that's a primary step. We're going to analyze huge amount of data and faster and better decision making. So it's going to help us better decision making in terms of financial returns, let's say for an institution. Then goes with a reduced production cost. There were no predictions, but rather we tell it in a more advanced manner and reduce the production cost in terms of manufacturing units and gain business insights. So there's like a huge potential data science has in terms of business, and build intelligence and ability into machines. So this is the need for data science from the previous case to that of now. So we saw why a science has to be put into data. That's data science. Now, what we want to see is what is a data science itself. So data science, known as a data-driven science, makes use of scientific methods, process, algorithm, and system to extract knowledge or insights with a goal to discover hidden pattern from the raw data. So when we are presented with a raw data, say for last year, so this was the price of stock market. When we are presented with that, our ultimate goal is to use a huge amount of scientific methods, process, and algorithms to extract hidden information that are not visible to our naked eyes, or as analyst himself cannot bring about the predictions directly. So when it is at that place where we come into this data science. So we saw what was science that has to be put into data, and why data science has evolved from the previous case till now. And we saw what was a data science. Now coming to data lifecycle. Data science provides a one-stop solution to all these operations. So what are they basically? So first we'll have to discover. So what's discovering? We with every click we are just putting a data onto the websites, onto the servers, knowingly or unknowingly. With every search word that we put into Google, we put data into Google servers. With every text message we put on WhatsApp, we add data onto the WhatsApp server. So our first step is to discover what are the different sources of data that we as users put onto the platform. The second step goes with data preparation. So initially we're able to now discover what are the data. Then with going to data preparation, we gather them, we organize them, we do cleaning, So that's the biggest process in a data science operation. And we are making the data suitable enough that a computer can understand, because a computer knows only zeros and ones. The hardware and CPU just understands binary operations, binary bit operations. So from a human understandable form to a machine understandable form is done in this data preparation. The third step goes with model planning. So in model planning, once a binary format of the data is obtained, we have to teach the computer to understand useful insights, or to draw useful information from the data. So that's basically done in model planning. So here we select the most optimal algorithm, or the most suitable algorithm for the given data. So it depends on the type of data, it depends on what are the insights that we want, what kind of output that's required. So based on that, we'll select a model. Then goes with the model building. So once the technique or the algorithm is defined, we then develop a model out of it and operationalize it. So we get the model to train, and we put it into operation, get some useful insights for a business perspective, and finally it goes with communicating the result. So ultimately, the say the owner of a shop should be able to tell, so this is what he's got a useful insight about. Next. So we have different programming languages for data science, like R, SAS, Java, MATLAB, SQL, and Python. So among them, like, what is so specific about Python? Why Python? So Python for data science. So the first and foremost reason for Python is, like, it's easy and simple to learn, that everyone knows. We are all like we know the kind of code that goes into C, the kind of code that goes into Java, and now the kind of code Python has. So like 10 lines of code in C or Java can just be put into one single line, right? So that's like, it's such simple to learn, and then it goes as a fit for many platforms. Like it's just one Python for Mac or Ubuntu or for Windows. And then it goes with, it is high level and interpreted language. So it's basically an interpreter based language. So these interpreter based languages help us in doing search operations in huge amount of data. So let's consider we have Amazon server, and onto the Amazon server I put a search engine as JBL Bluetooth speakers. So in the corpus amount of information, the data that's present in Amazon, the algorithm has to go search for a Bluetooth with a brand of JBL. So at that case, the interpreter based language gains an overhand than the compiler based languages. So these interpreter languages are able to do the searching operations at a very higher speed than the compiler based languages like C. So that's one reason Python is widely used. So it's high level, and it's basically a object oriented language and interpreted language that's making us demand Python for data science operations. Then goes with perform data manipulation, analysis, and visualization. So Python is like one-stop solution that is able to get us the data cleaning, the data pre-processing, and with same Python, I'm able to develop my model, I'm able to deploy my model, I'm able to test my model, and the same Python is also helping me to get useful insights for visualization. So it's like one-stop language for all the entire needs of a data science operation. And then goes with it has powerful libraries for machine learning applications and other scientific computations. Like as we all know, we have sklearn, scikit-learn, scikit-image, and now with the deep learning frameworks we have TensorFlow, Keras. So all these libraries give support to Python, which makes it more preferable, easy to learn for a beginner, as well as for the deployment in terms of deployment in the real world scenarios. And so the next we go with data science trends and what is the life cycle, right? So when we talk about data, so there should be some person in say any organization who's responsible for handling all these operations, right? So we have a teacher who teaches, we have a music master who teaches music in a school. So similarly in a MNC, there should be a person who's responsible for handling all this data stuff, correct? So that's nothing but a data science, like as we all know. So we'll just have a look at who the data scientist, or like what are all the features, or what are all the characteristics that a data scientist should have. So basically, the data scientist should be a person who has a strong hold onto mathematics, technology, and business. So why do we have a triangle of all this, right? So as we all know, data science works with algorithms. So it's basically some kind of mathematics that's involved into. It's a gameplay with zeros and ones. So definitely mathematics gets the upper hold. So the data scientist must have a mathematics background. Next goes with technology. So even though we have Max, he has to get himself adapted to the latest technology, the trend that is going on into the market, and the kind of newly developed algorithms. So it's very important that the data scientist also has a strong grasp about what are the current technological benefits, what are the current technological upgrades that is going on to the market. And ultimately, all the data operations and all the data science that we're doing is to get some financial returns out of it. Any company that uses data science uses it to get a financial benefit out of it. That's
Sandhya?
the ultimate
Sandhya, it
motive.
is Sandhya.
Amazon gives us recommendations. Yes, sir.
Yeah,
Yes, sir.
little bit slow because
Hello.
uh, Sandhya, are you able to hear Sandhya?
Yes, sir. I'm able to hear, sir.
Yeah, please a little bit slow because your speed they are finding it little bit faster. Uh, so
Yeah,
they
yeah, sure, sir.
as in the chat you can see it. They are finding it if you are a little bit slow, that's will be quite good. They have been commenting on that. That's the reason. Nothing else more.
Yes, sir. Yes.
Okay.
Yeah, sir, sure, sir. I didn't open the chat box. Sorry, sir. Sorry.
Yeah, please.
Yeah. Yes, sir. So like as we all know, like any firm, like starting from Amazon to Google to Yahoo to any firm that we use, the ultimate objective of getting all this data science is to get a monetary benefit out of it. Like when we get a smartphone in Amazon, Amazon automatically gives us a recommendation for a scratch card. Amazon automatically gives us a recommendation for a cover, right? When we buy a laptop, it gives us recommendation for a RAM, for a for say SSD card, and so on. So what is the benefit of using data science in Amazon? So when a customer buys a particular product, the company uses data science to urge the person to get the other product too. So this way they're increasing the sales. So like similarly, even coming to the industrial based benefits or coming to any platform, the ultimate goal or the ultimate aim of using data science is to get a financial benefit out of it. So that's the triangle that gets all the equal related and all the equal content, that's or the equal weightage for mathematics, technology, and business. So a data scientist should have a strong hold onto all these topics, right? Person, no, the data scientist has to have a stronghold in mathematics, goes with technology and business. So now taking an even deeper look at the skill set. So what are the ground level skills a data scientist should have? So as we saw, mathematics was at the top of the triangle, so which means the person should have a good grasp onto the statistics, because it's a gameplay of numbers. So we are ultimately at the end of the day, we are going to get some useful insights from the list of raw data from the numbers that we're having. So it's very important that a data scientist understands statistics and is able to get useful interpretations out of it. So when we say understand statistics, like what is basically understand statistics? Like let us say I have a data, and onto the data I say I have to take the mean of the data. So as a data scientist, we have to know, taking a mean in the data, what is it's reflecting. So when I take a mean value, what does it tell? So let's consider I have a list of data which tells the age of people who have bought Oppo smartphone. So when I take the mean average age of the person in the given data, we are exactly able to tell what is the average age of a person that will buy an Oppo smartphone. And similarly, when we go for Apple Mac, when we can get the average age of a person that's able to get that purchases an Apple Mac smartphone. So in this way, the company will be able to target those age group in a better efficient manner. So the ultimate goal of data science, the statistics used in data sciences, it's not merely using the mathematical algorithm, but rather understanding and interpreting what the mathematical part brings onto the gives a real-time interpretation. So when I put some mathematics, what is it interpreting in my data? So that's very important part to understand when it comes to statistics. Then goes with programming languages. So as we all know, we are developing algorithms that using some kind of programming languages. So and it's also very important that we have a strong hold onto the different programming languages, so that we're able to implement our algorithms in a more efficient manner. Then goes with data extraction and pre-processing. So as we all know, the raw data that's available in real time is like has lot of noise, it has lot of unwanted content present into it, and our target is to remove all the unwanted material and get the data extraction and pre-processing. So next goes with data wrangling and exploration. So like this is the most part that requires a huge task onto it. So data wrangling comes as a part of data cleaning that is happening. So what do we do basically here is, when I have a corpus of data, our target is to remove all the, let's consider we're having a huge list of data that's telling about the weather conditions in the past 1 year. And our target is to predict what would be the weather conditions for the forthcoming week. So in that case, there is a possibility that there are many data has not been recorded onto the system. So there was a lot of non-NaN value, that is nothing but not a number. When I'm having a series of data, there are many values that are not present. So in that case, we'll have to remove the not a number values. In the other case, let's consider the data basically has a numerical value, but in between we had alphabetical values present into it. So our responsibility is to take away the alphabetical values and keep only data. And in a vice versa, when the data has only alphabetical values and I have numerical value, how do I remove it? So data wrangling and data exploration is basically to clean the data, and the next step after cleaning is to obtain like useful information out of it. For example, we have a government data that has about the people who, when we're getting voter ID cards, right? We are having elections in the next forthcoming year. So the government now is going to estimate what is how many number of voters are currently active in our country. So for that, when he has to sir, am I fast?
Yeah. You're a little bit fast, please.
Okay. So let us consider the government is taking a list of who are the active voters, active people who can vote in the coming year. So when we take the voter list, what are the informations we have? We have the name, we have our father's name, we have the date of birth, and we have our address. We have so much amount of information. But basically, to identify whether a person can vote or not, what is a fundamental thing? We have to check out the age of the person. So out of all the columns of data that we have, age is only the required component. So it is more than enough if I take only the age data, or the column which corresponds to age, and leave out the remaining value. So identifying, so what we saw now was a simple example, just getting the age of the voters in a given data. And similarly, when you go for real-time data, when you go for other data predictions, like identifying the exact data to be analyzed is a very, very important task. So for this task, it is important that we have a strong hold about the application that we are deploying also. Let's consider for we are going to predict or we are going to forecast how much amount of wind power will be produced from a windmill. We are having say 2 acres of windmill, and our target is to estimate how much amount of wind energy will be produced in the next week, or say in the next month when there is a windy season. So in that case, we have a collection of data that has about wind speed, that has about wind direction, and also the turbine output power that was produced from the windmill. So we have 3 sets of data. As a data scientist, when we are applying a data science algorithm, it is very important for us to pick out the correct attribute that is required for our processing. Whether I'm going to take my wind speed, or whether I'm going to take my wind direction, or whether I'm going to take my turbine output, or whether I'm going to take all the 3 into account. So to identify what is the exact attribute that I want to use, it is important for us to have a good understanding about the application domain. So here, when I'm calling a renewable energy engineer, when I call a person who has a well-versed knowledge on wind power, and I get some useful insights or get some advice from him to know which attribute or which metric I should take. So it's a combination of both the application domain based knowledge as well as the exact way of picking out or exact way of extracting the required information from the whole corpus of data that we have. So this is the most important part and most time consuming part in any data science based operation. So that's data wrangling and exploration. So once we've got the data, then we go to apply some kind of machine learning algorithm. So here comes our analytical part. So the data that we have extracted, we're going to put into the machine learning algorithm, train the algorithm, and make the algorithm give us useful predictions, give us a required output, and identify the hidden pattern that was present inside the data. So let's consider with wind energy forecasting. So once we select the most optimal metric, let us say I consider wind speed. I'm going to take wind speed and get the useful insights about how much wind energy will be produced in the next week. So in that case, we just use the machine learning model to predict how much will be the wind power produced in the forthcoming week. And then finally it goes with big data processing frameworks. So as we all know, every person and every smartphone, like every smart device around us, is generating huge corpus of data. Like we speak so much to Alexa, right? So all that goes to huge amount of data. So we need to have big data processing frameworks to save the data and get useful insights out of it. Then finally it goes with data visualization. So once our predictions has done, once we're able to get useful insights, and finally we go with visualizing and getting a better understanding about what our data is trying to tell to us, or what are the useful patterns we are obtaining from the data. So on a summarization part, the data scientist, or in a industry, should have a good hold of statistics, a combination of programming language. He should know how to extract data from real world, process it, and after extracting the data, he should have a good understanding about getting the most required data from the given corpus of data. Then using the extracted data, we'll have to apply to a machine learning algorithm. And once we have got some insights, we should also have a good hold about how these big data processing frameworks work. So in this big data processing frameworks, we have a lot of database structures like MongoDB. We have structured query languages, and also data visualization. Like even now, when you check out for some LinkedIn post that ask for say data scientist in any firm, nowadays the kind of requirement that we get is a combination of both Python and structured query languages. So in previous days, it was enough like if a data scientist knew Python, but whereas now with the kind of big data work that we're going, the industry trend is shifting towards a data scientist who has a good hold on Python, as well as who has a good hold on structured query languages, or like processing, or like some kind of language that he has on handling these big data. So it's, as a data scientist, it's important that we go have a programming language and a combination of the structured query languages or database languages to get a useful insight from the given data. So like as we all know, previously there was no role called a social media manager in a given firm, but rather nowadays we have a separate role itself as a social media manager, just to maintain a social media accounts, right? So in previous days it was just like one role. If I say data scientist, that's all. We go to a Bosch, I say it's a data scientist, that's all. I go to some firm, I say I'm a data scientist, that's all. But like that is not the case now. Inside data scientist itself, we have different divisions, we have different streams, we have a huge amount of positions that we split our data. So we previously we saw that the entire process a data scientist does itself a lot. Like initially we collect the data, we do the extraction part, we get the useful information, we develop some algorithms, and then post the algorithms, we get some useful insights, and then after that we are having a visualization part, and finally we go with the real-time deployment. So now the companies are moving towards a trend where each individual task is done by each individual person. So a data scientist is basically a person who has a strong hold on all these areas. Like what we saw previously, he is a master of all trades, he's a jack of all trades, so he knows, he has a good hold on every part. So next, coming to data analytics. So what a data analyst basically does is, the analyst does not develop algorithms, but rather gets useful insights about the data. That's all. Like she just applies some kind of statistical techniques, some kind of interpretations to know what the data is basically trying to tell. So identifying some hidden information that's not like directly visualized, or that's not directly interpreted when we are looking onto the data with a raw eyes. So analyst basically analyzes the data. Now coming to the data architect. So this data architect is mainly concerned about developing the most efficient data storage structures. Like many of us would have seen the warehouse Google has, or the web servers and the Facebook has in their um, in Mountain View in USA. So it's very important that we develop most efficient algorithms that are able to get the data onto the server and also retrieve the data at the fastest speed, right? So this data architect is responsible for handling that huge data, and the data engineer goes with developing the machine learning algorithms. He basically engineers the data to get useful insights out of it, and is responsible for developing those machine learning models, getting the analytical models into the work. Then goes with statistician. So he is mainly concerned with the statistical part. He puts the different kind of metrics onto the data and gets a good understanding about what the data is basically trying to tell. So what is the average age of voter in India? Like what is the deviation between my previous what is the deviation between my yesterday's gold price and today's gold price? So that goes with variance. Then standard deviation. So he does this kind of statistical part and gets interpretation out of the data that we have. Then goes with database administrator. So he also goes with handling the database management into the servers, or when we are processing the huge data. Then comes to the business analytics part. So as we saw, data science was not just getting the algorithms into work, but also getting some monetary benefits, financial benefits into work. So increasing my profit turnover, or increasing the kind of sale that happened. So Amazon uses it to increase sales, right? YouTube uses recommendation system to increase the number of watch hours that we saw. Like previously YouTube had an option to skip ad, but nowadays when certain ads come, we don't have an option to skip itself. We don't find the button called skip ad, right? So through this, what happens, the revenue that we get out of ad increases. So this monetary benefits that we get from data science is basically analyzed by this person called data analyst. Finally goes with data and analytics manager. So this person concerns with the analysis of the data as such. Next, coming to a data life cycle. So we all talk about data. We all saw what and all the data is capable of, and we saw about data scientist and all those stuff. Now we'll just have a quick look at what is the life cycle of a data. So let us consider I'm doing a Google search onto my Google search engine. So I'm just typing today's gold price. So that today's gold price, it's itself a data to Google. Correct. So Google makes sure, so with this Google tells us what was the most searched word, right? So like every year end, we also have analytics that's put by Google, which says what is the most searched word in the corresponding year in India or all over the world, right? So like we'll just have a look now. When I put a word onto the Google server, which is my data, which is my personal data, and what is the life cycle it has, right? So we as individual users, we put huge amount of data onto Google servers. So we'll have a look at what is the life cycle that the data has, right? So initially it goes with data acquisition. We start with data acquisition. So in data acquisition part, we acquire the data. That's nothing but Google gets the data from our web address. Then it goes with data processing. It does the clean part of it. So it is from my web address, which goes to hit the Google server. It is now extracting only the word that I typed. So when it's going to the server, it goes in different format. It goes in packets. It goes in a different way. So from the entire that data, it's only getting my search word first. For example, let us consider our Gmail account is synced with our Chrome web browser. So what are the information that goes to Google? The first information is what Gmail account it is, right? So what account I've logged in. So that is one information. The second information is what was the word that I was typing. The third information is what was the time duration with the time of the day that we were typing. So it also depends whether you identify the gold price at the beginning of the day or at the end of the day. So that is also a data to Google. So all this information combined together will hit the Google servers. So from that, Google does the pre-processing operation to get only the word that I typed. So what is today's gold price. So that's data processing. Now it goes to data exploration. So similarly, Google sees like how many people have searched for this data. So it does, let's consider we're doing a text classification to classify how much search words were typed related to business, related to entertainment, related to music. So Google collects similar keywords that were typed by millions of people, and using the text data that was obtained, it does a classification algorithm to classify the words that we typed. So that comes into modeling. So once it identifies, it now deploys, right? So now it has developed the classification algorithm, and that classification algorithm will be deployed onto the Google's internal servers to identify what were people searching, or what were people looking for in India, on more precisely what was people looking for, what were people looking for in Tamil Nadu. So like this is the kind of algorithm that is even deployed in Twitter. We all see trending topic in Twitter, right? So we see hashtag number one, so and so is trending, right? So like every tweet gets into a data, and it goes to the cycle, and finally the the data is, I mean the algorithm that classifies, or the algorithm that determines the most tweeted hashtag. So it identifies this the most tweeted hashtag, and the algorithm that was developed for this will be deployed onto the Twitter servers. So like this is the kind of life cycle that a data has. So as we all know, so the first thing about a data lifecycle is business requirement. So we basically have to understand what is the problem that we're trying to solve. So this is like the primary task for any data scientist, or for any data science operation that we're doing. Like it's very important that we identify what problem I'm trying to solve. Let's consider wind energy forecasting. So we have to first recognize, or we have to identify that as a data scientist, our role is to identify what is the forecast of wind energy in the forthcoming year. Or let us consider on a stock market price. So what is going to be the price of my stock market tomorrow, in terms of like consumer based analysis? So what is the next product that my customer will buy after she buys a laptop, right? So identifying the business requirement is the first step. Then goes with data acquisition. What data do I need for my project, right? So let's, for wind energy, like we saw, wind speed was one of the data. To In a recommendation based system, our mouse click, right? So that will be your data. And say for a stock market prediction, the previous stock market values will be your data. So once you have got the business requirement done, the next step is in acquiring the data that is required for our problem. The next goes with data processing. We've already discussed. So once we've got the raw data, we'll have to do the cleaning. So the different cleaning operation is finding out the missing value. We might sometimes have a corrupted data, and the data that was corrupted because due to some transportation issues, like when we are transporting it wirelessly, sometimes the data can be corrupted. So this happens when we are downloading, right? So when we download, sometimes the file becomes corrupted. So like similarly, corrupted data, and remove the unnecessary data. So like these are some of the basic cleaning operations that we do on data. Then goes with data exploration. So we understand the patterns that's present in the data, like that is what we want, so that is what we look for, and then retrieve useful insights out of it, and do some hypothesis. So hypothesis is nothing but building analytical models to get the useful insight. And then goes with modeling, to determine optimal features for the machine learning model. So we have to select the best model. Say when I'm going to identify what is my trending Twitter tweet today in India, so we have to develop a certain text-based model, or NLP, natural language processing model, that does the text operation. But rather, when we let us consider, I take a photo and using a cam scanner, and we are now doing some image processing based solution to increase the light intensity. Or we have a lot of photo apps, we have face app. So in those cases, the input data we have is a image based data. So in that case, I have to look out for some deep learning based model like CNN that is doing my image processing based operations. So depending on the data that we are having, we have to select the most correct or the most optimal algorithm for our given data. So determine optimal data features for the machine learning model, create a model that predicts the target most accurately, evaluate and test the efficiency of model, and finally goes with deployment. So check the deployment environment for deficiency issues, and deploy the model in a production test environment, and monitor the performance. Like for example, all of us have smartphone, and we all take selfies, right? So when we're taking the selfie, if you guys analyze, we always have a bounding box drawn around our face. So like that's one of the basic image processing based algorithm, that is a face detection or predicting or detecting where a bounding where the face is present in a given image. So this is a this is a machine learning based algorithm again, but here the deployment was onto the edge device. Like all of us never even analyzed that the machine learning model is already deployed onto a smartphone. We have lot of apps that come with smartphone. We have face detection, face unlock based smartphones. So in all these cases the machine learning model was deployed onto the edge device itself. So this is one deployment environment. Whereas let's consider recommendation system from Amazon. So here the machine learning model is deployed onto the Amazon servers, onto the Amazon cloud. So ultimately, after developing a machine learning algorithm, there are only two ways that we deploy. One is we deploy onto the edge devices. We have huge amount of edge devices now, like Raspberry Pi based solutions and single board computers. So those are one range of edge devices, including our smartphones. We have smart watches now. We have different wristbands. We have a lot of intelligent devices, like smart devices, coming into our environment. So all those edge devices are one deployment platform. Another one, when you're going for a web-based solution, the deployment goes with cloud, right? So now we've just had a brief introduction about what a data is, what science has to be put into data to get a data science, and what a data science is. We saw who a data scientist is, what are the different positions that we have currently in different MNCs for data science. We saw about the characteristics or a skill set a data scientist should have. Post that, we saw what are the life cycles that a data science that a data itself goes through, right? So this is like a brief introduction about data science. So like participants, do you have any queries, or do you want any discussions?
Participants, if you are having any query, please send it in your chat box so that we can ask our speaker to answer to those questions. Or shall we, before finishing the session, shall we have it? That's better, I feel it.
Yes, sir.
Yeah.
Sure, sir. We'll continue.
Once again, one question has come from Dr. GL Murthy. In industrial manufacturing, what data science can do?
Yes, sir. So like data science in industrial environment is like the biggest, most exploited space. Like in the previous industrial environment. So let us consider a case where we are having let us say a oil processing industry. So let's consider we are extracting petrol from crude oil. In the previous industry, in the previous case, like in the traditional ways, there used to be different chemical process that goes to identify the different, to monitor the different process that happens, and we get it. But in that case, like most of the examination that we were doing was manually done. But rather now, with the penetration of IoT, right, Internet of Things and industrial Internet of Things, and we have AIoT, artificial industrial Internet of Things, what happens, we deploy smart sensors in every possible place. So in those days we didn't have flow sensor, right? In those days we didn't have a temperature sensor. In those days we didn't have a pressure sensor. So what happens, all these sensors act as different nodes to capture information, and every information that's obtained from every sensor is itself a data for us. Now what happens, lot of industries use the information from sensor, which is basically an IoT, right? We get IoT out of it, and then we use the sensor to obtain useful insights from it. I can even like share you a real-time example, right? We have like we were actually working with a project where we were using a flow sensor to detect a leakage from a gas. It was basically a gas-based processing firm, and it's very important that we identify any leak present into the tubes. Okay, so we measure the operations that happen in the gas using the pressure of the gas that's going. So it's very important that we detect if the pressure has decreased. So when the pressure decreases, or when there's a variation in pressure in the tube, we indicate or we identify that there's some leakage happening in the gas. So before manually a person comes and identify that some leakage is happening, what we do with the help of sensor, we continuously monitor the pressure, air pressure, and the flow that's happening inside the sensor. And immediately when we use it for deep learning algorithms again, so I just get the data, put it onto the machine learning models, it's continuously processing. Instantly when there is a drop or when there's a variation in pressure, we give alarm to the person. So instead of manually checking for the data or identifying if there is a leak. When we use sensors like this onto deep learning model, we are able to prevent huge amount of accidents, risk, and help us identify the quality of the tube, and it's like huge wide use case. Yeah. So I think I'm answering to your question.
Yeah.
Yeah.
Sandhya, I think questions are coming up very faster. We'll
Okay,
take
sir.
it up as soon as your this one is over. There is presentation related to the Python is completed over there, the tutorials and other things over. Okay.
Yeah, sir. Sure, sir. Sure. So we'll just have a quick look about Jupyter Notebook. So most of us are familiar about Jupyter Notebook. We've all used them, or we have seen them in one way or the other. So we'll just have a quick recap about what the Jupyter Notebook is and why did it basically evolve, right? So in earlier days, there were a lot of scientists in that days also. So what were these people basically doing? We were doing some kind of analysis onto the lab, and we had some notebook to record it. So the experiments were done in a different place, and the a notebook was separately used to write the interpretations or do the analysis part of it. So that was with the earlier days. But now what happens in current scenario, both the experiments and the notebook has come into one place. So that is Jupyter Notebook. So that it's the name itself which is notebook. So what are we doing here? Let us consider our notebook. We have all used notebooks in our school days, correct? So let's consider a Max notebook. So what do we do in Max notebook? We write some formula and we write the elaborations of the formula below itself. Right. So I have my text data, I mean some content, some textual content to understand my equation below it or beneath it itself. In the previous IDs that were used, like PyCharm or like other IDs, what happened was we also had option to put this text content in the form of comment windows. Like I have to put a hashtag and then comment it. So it's not a kind of a notebook format. It's only a code editor format. So this problem is overcome by Jupyter Notebook. So what Jupyter Notebook did was it had two different options. One place to write our text data, to write our keynotes, to write the key points, and the next place was to do the experiments, the coding part basically. So it's a combination of both my experiment place as well as my notebook place. So that's the reason why Jupyter evolved from the other things. So like if you see, initially it was launched by the IPython framework. It was initially put out as IPython IDE, and from that it evolved to what is now called as Jupyter Notebook. So initially when IPython was proposed, or like initially when it was launched, it supported 3 languages: Julia, Python, and R. Like even now Jupyter Note supports like R. So the combination of these three first letter term itself is Jupyter. And JU for Julia, PY for Python, and R for R programming language. So that's the history of how Jupyter Notebook came. Most of us should be familiar with Anaconda Navigator, right? So it comes with Anaconda package. So it's a package that has that comes with support to numerous languages with inbuilt libraries. So in this, you download Anaconda Navigator, and then you open the Jupyter Notebook presenter into it. So you just launch it. So what a Jupyter Notebook basically has is it's fundamentally a JSON file, technically talking, with a lot number of annotations, right? And it consists of a metadata. It has a list of cells where we do the experiments, and it also has a notebook format for us to write the important interpretations and key points, right? So this is how a Jupyter Notebook looks, so we all know. And like we have 3 tabs basically: file, running, and cluster. File has a list of all the files. Running will tell us what file is currently being executed, and then it goes with cluster that we have grouped them if we have grouped any. And upload helps us upload new document. New helps us launch new Jupyter Notebook files. And as we all know, Jupyter Notebook ends with IP, Y, and B, and it tells about the last modified, name, and the file history. So this is a short introduction about Jupyter Notebook, and with this we'll now move on to the hands-on sessions. So I think participants, you should be receiving a bunch of Jupyter Notebook files that has a basics about NumPy. So I request you all to download those files and upload it onto your Google Drive.
Sandhya?
So yes, sir. Yes, sir.
So there are certain questions related to the Google Colab and some Jupyter Notebook. You can just take over in that question immediately over there.
Yeah, sure, sir. So
You
what is the
cannot
difference
do it directly.
between Google Colab and Jupyter Notebook? So actually Google Colab itself is a Jupyter Notebook. The only difference is when we install a Anaconda notebook and I open a Jupyter here. So what happens? This Jupyter runs on our computer here. That is on our local host. Like you can see local host 888/3. What happens with Google Colab is Google Colab is also a Jupyter Notebook that runs onto Google server there. So what happens? Google allocates a special VM, a virtual machine for each one of us, and in that, the virtual machine is basically a Linux computer, Ubuntu computer. Now Google has its huge database. It partitions into different VM, and in different VM, it is allocating one particular Jupyter notebook for us. So the only difference is here I run it on my computer. When I'm opening Anaconda Jupyter notebook, it runs here. A Google Colab is nothing but a Jupyter notebook again that runs onto a Google servers. And the benefit of using Google Colab is that it gives support to GPU, right? They give Tesla K20 GPU, right? So that's it gives us a platform to work with TPU, tensor processing unit, GPU, graphical processing unit, or with CPU. So all the three platforms. So that's the reason why we go with Google Colab, and it's basically a Jupyter notebook itself. Now Jupyter is run locally in personal computer, which uses the CPU to run the program. Whereas Google Colab has a cloud. Yeah, I think Shiva has answered to your question, right? So can you share the link to download the required software? Yes, surely I'll put it in the chat box here. Okay.
Sandhya, we are sending you your all your content and other things are being sent to the respective email ID where they can download it. Okay.
Yes,
now
sir.
itself we are sending it.
Yes, sir. Yes, sir. I've shared it in the morning, sir. Like I shared it by.
Yeah. You shared it to Dinesh, and Dinesh is sharing it to their mails.
Yes, sir. Yes.
Emails. In their email, they can set it. Chat box liye share பண்ண சொல்றேனா? Chat box liye share பண்ண சொல்றேன். வேண்டாம். அங்கேயே ஷேர் பண்ணுங்க. நீங்க எதுக்கு இதுக்குள்ள போய் ஷேர் பண்றீங்க? ஃபைல்ல இருக்குல்ல, கேக்குறாங்க அவங்க இங்க.
So participants, now a screen with Google Drive should be visible now. I just want to have a small check. Is it visible?
Yes, please. Yes, please.
Okay. So for those of you who are new, I'll just have a small, most of us are familiar, but I'll just have a small recap about how to open the Google Colab. Okay, so Google Colab comes as an application that's deployed onto a Google account. So we just need to have a Gmail ID to open the Google Colab. So all of us are familiar with that. So we go to new tab here and then come here to more. You find Google Collaboratory. So if suppose this is the first time that you're using Google Colab, you have an option called Connect More app. So when you go to this Connect More app, you'll have a search app here. So here you type on Collaboratory. So you get Collaboratory here. Yes, so it's already installed. So if it's not, you'll have option for installing or adding onto your Gmail account. You just need to add it. So through this way, Google Colab will be added onto our existing Gmail account. So after this, what we do, I just go to new and come to more here. We'll have an option called Google Collaboratory. So when we click on here, so a new Colab file opens for us. So most of us would have are already familiar with the Colab environment. Just a quick recap. So a Collaboratory basically comes with a Colab is basically a Jupyter notebook itself. So that's why we have an extension as IPYNB. So IPython notebook. So IPYNB, we have an option for file edit, insert runtime. So most of us are familiar. There's one important point that I want to just have a quick recap. So always when you open a Google Colab, if you want to use GPU, come to runtime, change runtime option, hardware accelerator, GPU. So for those of you who are new, I just want to make sure that every time you open a Colab notebook, make sure you select GPU. So because CPU is already present in our computer, Google gives us a free GPU for every person with that's a Tesla K20. So always ensure that we have selected GPU when you're getting the getting the collab running for the first time. So we select the code and text here. Code goes with running, or text goes with the textual part of it. So this is like the basic intro, and we can just have the features, different features looked while we are going through the different slides, right?
Sandhya,
Yes, sir.
screen is not shared. You're about to share.
Yes, sir. Yes, sir. Yes, I'm about to share. I'm about to share. Okay. Yes, I'm repeating the process again. So just a minute. So all of us have a Gmail. I mean, all of us have used our Google Drive, right? So all of us are familiar with a Drive environment. So we go to our Drive environment. We have an option called New. So we just click onto the New. We have an option called More here. We come to More. If it's the first time that we are loading a Google Collaboratory, just go to Connect More Apps. We'll find an option called Connect More Apps. So click on to Connect More App. In the search box that is here, just type Collaboratory. Click on to Collaboratory here. You will find a symbol which goes with C and capital O in a yellow color format. So I've already added, so it's not showing here. So you can just click install or add, and it gets added to our Gmail access itself, to our Gmail account. After this, we just give new again. Come down to more. We have an option called Google Collaboratory. So we just click on to this, we'll be able to get our new collab file. So basically the current GPU that we're having is free. It's free of cost. And it comes with 12 GB RAM and Tesla K20 with some 30 GB hard disk storage, 30 or 300, I'm not sure with that. So it's not chargeable until now. So Collab has now given out a feature called Prime. So in Prime, what happens, our RAM gets extended from 12 GB to 25 GB. So for Prime, they give us we are charged, or we have to pay monthly some dollars. It comes in three format: monthly, yearly. So it goes on different basis. We just have to pay so much for us to have a better access onto collab file, and for us to increase the RAM. Now when we give a GPU in the basic format, now it is not chargeable, but rather if we want to have a higher RAM, at that time we can go with go for collab Prime. Sir, actually I'm not checking the chat window constantly. If you have like any doubts, like kindly do
Sandhya, we are watching it all the chats. Accordingly, we will keep in touch with you. You can
yes, sure.
Yeah, please. We can go.
If there's anything, kindly do let me know.
Because at least by 11:15 we should be able to finish off and go to the next session. That's the reason.
Sure. Yeah, okay. So the first file goes with the IPython basics. So there will be a list of files that are actually numbered. We'll have numpy _1, numpy _2, it goes on, and so on. So that's the basic. That's the kind of order that we'll be going for today, right? So I'm just quickly walking through this particular file, IPython basics. I'm not going to spend a lot of time, because all the content that is here comes with inbuilt explanations. So even after the workshop, if you open the file, if you just read the explanation given here, it's more than enough. It's kind of self-explanatory, and it will help you recall the content at any time, like post any point. So I'll just quickly walk through the code. Run through the cell so that we have time to spend on the other parts. So first goes with accessing the document. So what we do, if let us say I want to identify or I want to understand, Python has a lot of inbuilt functions, right? We have length, we have square root and so on. If I want to identify what a particular function is, I just have this thing called question mark. So it helps us identify the, and it helps us access the documents, and also it helps us access the functions. So that goes with that. And also we can access the source code of a particular function. So like we're having a square here, and when using the question mark, we are able to get the source code behind it. Then goes with tab completion. Like let us consider I'm typing a particular l dot append of. So append is a function that comes with list, that's inbuilt. When I type till app and I press a tab, it gets auto completed automatically. So that's about append. You just press tab for us to auto complete. The same goes with address also. Like when we are giving our address for corresponding file that's there in a remote location, we can just use tab to auto complete our address. So next goes with tab completion when importing. And as we all know, Python has a programming language that comes inbuilt with huge amount of libraries, and we always import lot of functions from different libraries. And while we are importing, if we can use tab also to auto complete our functions. That is tab completion while importing. The next goes with navigation shortcuts. Like these are the different navigation shortcuts that you can use onto the Jupyter notebook. Then goes with text entry keyboard shortcuts. We can refer it for the text-based processing. And then goes with command history shortcuts. Then these are all like searching. Like we would have typed a particular command in a notebook, and we want to search what command we typed. For those of you who have used MATLAB, we always use up arrow mark, right? We just use up arrow mark to see what was the previous function or what was the previous command that we gave, and we just instantly put an enter and the command goes. So similarly, we can use this history shortcuts to get the previously typed function. That's similar to what we do in MATLAB. So there's a both reverse search and direct search. Like even if you open a new Jupyter notebook, the search history will be able to retrieve what was the command or what was the function that we typed in the previous notebook. So it even has that option. So that's given here in the explanation. You can just have a quick look. And then goes with there are a few miscellaneous shortcuts for clear the terminal screen, exit IPython, interrupt execution. And then there are like certain magic commands. So I just want to stress on this. Most of us do a lot of copy paste within the cells. Like we copy one particular function to another particular function. So as we all know, Python is an indent based language. We don't have curly braces for loop, but rather indent is the function that will differentiate my looping statements, or the differentiate my control statements, say if statement, for statement, def functions, with, and so on. So in those cases, the indent is very, very important, and it is also very important that I don't mix up between my tab and enter space. Most of us have this issue. We would have pressed tab for the first indent, and whereas for the second one, we would have pressed enter.
Sandhya?
So it's important that using tab or enter, either we use tab. Yes, sir. Yes, sir.
Some disconnection was there. That's the reason. Just to want to check. Nothing else.
Okay, sir. Yes, sir. So in that case, when we are doing a copy paste thing, right? If we use this particular command called percentage paste off and cp paste off, this automatically takes care about the indent regarding to the indent based issues. Like when I do this paste off and I do this def function, it automatically take care about the indent return should have. So this is about paste, and this the same thing goes with copy paste also. Like a command that is similar with a similar intent to copy paste, which opens up an interactive multi-line prompt in which you can paste one or more chunks of code to be executed in a batch, right? So that's about copy paste. And this is about running the external code. It's again a feature like what we saw in copy paste. And then goes with timing code execution. I just want to stress 2 or more minutes. Like we as researchers and we as research community people working onto data science, our timing duration is very important for us. We want to know what was the time that a particular for loop took, or what was the time the algorithm took for executing a task. Like when it comes to research based applications, it's very important that we develop most less time consuming algorithms. So in such cases, to monitor the time that every code took for can be done with this timer operation. So it will be very helpful for us when we are working with our research based activities to identify what was the time that every for loop took. So when I just give timer and give the command, it gives us how much was the microsecond for per loop, right? So there's an inbuilt feature which we all can exploit in Jupyter Notebook. Then these are called magic functions. Then we call magic. So what this magic basically does is, like a normal Python function, IPython magic functions have doc strings, and this useful documentation can be accessed in standard manner. So it's basically a documentation that we're getting out of it, right? Then goes with Python inert objects. So we are all familiar with it, right? We have the output coming after each cell, and there's some more technical content related to it. And then goes with underscore shortcuts and previous output. So this is about what underscore does, and what underscore does with regard to the previous outputs. And then we can also have the function of suppressing the output. So basically, if we put semicolon, the output gets suppressed, right? And so it's something more related to the magic command. And as we all know, basically these IPython notebooks also support a wide range of shell commands. So only difference is, all the shell commands that we use onto an Ubuntu terminal can be used in Google Colab also, and some commands can be used in IPython also. The only difference is we should always use an exclamatory mark before the command when we're using it in IPython. Whereas ls, for example, ls is a list function. So whenever I'm using my shell command in a Jupyter Notebook, it's very important that I have a exclamatory mark before it. So when I put this exclamatory mark, I'll be telling the Jupyter Notebook that Jupyter Notebook, the command that I'm going to type after this corresponds to my shell based command. So this exclamatory mark is the one that differentiates it. So it's very important that we use this before we put any shell based commands. And passing values to and from the shell, we also have this option of passing the values. Then shell related magic commands, we have some magic commands related to shell based also, like pwd, print working directory, change working directory, change working directory to some corresponding directory, make directory, copy, list, and remove. So these are all the basic operations that will help us work in a better manner in our Jupyter notebooks, right? So we'll come to the NumPy. So participants, like as I told you, the sessions that we'll be seeing after this will be a combination of both linear algebra and introduction to Python for data science. So the content here that we have got is in a format that when we are seeing NumPy itself, we'll see the different operations that we can do with related linear algebra in NumPy. So it will be like both hands-on linear algebra as well as get you that into NumPy too. So post this, before we close the session at 1 o'clock, we'll have even like in-depth explanation about the linear algebra thing. So as we all know, NumPy stands for numerical Python. So where we'll be using numerical operations to do our task. So I just want to pause a minute here and give a small intro about Python machine learning libraries. So as we all know, we've heard about NumPy, we all know about pandas, and we're familiar with matplot, and we're also familiar with sklearn. So these are like the most widely used libraries with related to Python for implementing the data science and machine learning algorithms. So I just want to give some basic understanding about what library to use when for what kind of data. So we primarily opt NumPy when we have array kind of data. That's basically where we access the data with related to position and index. When we have a multidimensional data in terms of array, ND array, multidimensional array, in those cases we opt for NumPy. But rather when we have a kind of category, or when we have a kind of row column based data, right? When we have a structured data, a row column format based data, in those cases we go for a pandas framework. When coming to sklearn, so sklearn is widely used for deploying deploying machine learning models for a real-time task. So after getting the data, so I get real-time data, I either use NumPy or I either use pandas framework to convert it in a form that can be used into the deep learning model. So once we get that, we put that into sklearn based library, we train the model, and after training the model we'll be getting useful interpretations using matplotlib or cbound. So these are the basic libraries that every data center should have a stronghold. NumPy for numerical array based task, and pandas for row column based text, or for row column based documents, row column based data, and sklearn for machine learning models, and matplotlib for getting a visual interpretation of our data, right? So when you go to NumPy, we'll have a small introduction about NumPy in the basics, and you can use this command to identify what NumPy version you are using, right? So just a quick check. Is my screen visible now? It should start with something called understanding data types in Python.
Yes,
Is
ma'am.
it visible?
Yes, ma'am.
Yes, it's visible.
Yes.
Please.
Yes. Okay. So before we go for understanding the data types in Python, I just want to spend few minutes in getting us a basic difference between what a Python and C programming languages. So because like most of us are familiar with C, we have used C in our starting from our school days itself. So as we all know, C is a compiler based language, whereas Python is a interpreter based language, right? So every one of us should remember this: int a is equal to 0, int b, int c, and so on. So what we do here, I'm declaring a variable called result, and I'm predefinedly telling my compiler that result belongs to a data type called int, right? But whereas when you do it in Python, we don't specify the data type beforehand, because Python is a dynamically inferred programming language. So I need not tell my computer every time I declare a new variable what the data type of my variable is, but rather it's able to dynamically infer it. So that's one primary difference between our C and our Python code. Suppose this, like as we can see, we declare x is equal to 4, we declare x is equal to 4. When we are doing it in C language, we say x is equal to 4 is an integer, but rather when we do x is equal to 4, it says it fails, we give an error, because 4 is a string based data type, right? But whereas in Python, it accepts x is equal to 4, it also accepts x is equal to FOUR. So it's dynamically inferring whether the given data is a string or whether the given data is a numerical one. So that's one fundamental difference between C and Python, because it's a dynamically inferred language. Next, coming to, so there's something more about integer in Python, right? So Python integer is not merely an integer, but what it is it is actually an object. So the standard Python implementation is written in C. So basically Python itself is built on top of C. So right, internally if we go, we'll actually find GCC running behind it. So GCC, right? So the standard Python itself, sir, is the screen visible? Is everything fine?
Yes, ma'am. You can go ahead, ma'am.
Yes, sir. So Python integer is not just an integer itself, but rather it is a Python. It's an object to a C structure. So we're all familiar with structures, right? The structure is a data format that is able to hold on to a data format that can hold different types of data onto it. Like I can put a string, I can put a integer based data into one data pack. So that is a structure in C. So what integer in Python is with respect to C. So we're trying to kind of map the relationship. So in that case, we know that a Python object is simply a clearly disguised C structure. So this is a normal C structure, right? So a Python object is nothing but, integer is nothing but a Python object, right? So this like helping us have a better understanding. So just a small comparison. In C, what we do, we just have a integer. When I say int a is equal to 1, a integer with say 2 or 4 bytes of memory depending upon the compiler will be allocated, and we just give the memory for it. But rather when I say a Python integer, it's a digit, and also a Py object head will be allocated along with it. So that's the kind of a difference that is happening internally while storing the data, right? So as we all know, Python has three major data structures. One is list, the other one is tuple, the third one is dictionary. So list is a mutable, it's a mutable data storage format. Tuple is an immutable data storage format, and dictionary has something as key and value to search and get a data. And these are fundamental data structures in Python. Other than that, we have some more structures like sets and so on, but these are the widely used three structures in data science. And depending on the application or depending on the task, we either go with the list, or we either go with tuple, or we either go with a dictionary for our application. So let's consider what happens when we use a Python data structure that holds many Python objects. So the standard mutable multi-element container in Python is a list. So basically a list is nothing but it's a mutable. So mutable means I can change my value, or I can modify the value present in my list after declaring it. So initially I give a list, say A is equal to 1, 2, 3, 4. And list gives me an option of removing the first element as 1 and replacing it with 100. But whereas with tuple, I cannot remove 1 and replace it with 100. So it is immutable, which means I cannot replace it. So once it is declared, it's declared, that's all. But rather list gives us the option to mutate it, we can change it. So the standard mutable multi-element container is a Python list. So list is basically a container itself, it's a multi-element container. So we all know this is how we declare a list. L is equal to list of and range of 10, and we get a list declared of 10 values. And similarly we can put it for a list of string, and also a list is not list is independent of the type of data. We either have integer, we either have string, or we either have float value. It can be a list of list also. I have different list and I stack it inside one big list, so it can be in that way also, right? So because of Python's dynamic typing, we can even create heterogeneous list. So also it's possible that we have a different type of data packed onto one list also. So these are the different operations that we can do with list. Now coming to a basic difference between a NumPy array and list. So as we all know, what is an array? Array is a homogeneous structure. It is not going to allow different data types to be packed into one data structure. That is, I cannot have a string, I cannot have a float, I cannot have an integer combined as one entity, but rather list gives us an option to do that. So that's one particular difference. And the second difference is how internally my data is getting stored. When you're taking for a NumPy array, we have a Py object head, we have a data, we have dimensions, we have stripe. So data starts from here and we go on, but rather how list internally stores is, we don't have dimensions and stripe, but rather we have list, we have length, we have items, go on. So most of us would have encountered this error, like we will be having a list. If you just give a type of, or if you give a shape of, so we just when you're having a list in Python, right, you just try giving the shape of a particular list, you'll get an error, because a list will not have a shape, it only has length. So internally how it gets stored is, a list will not have multiple dimensions, only a NumPy array will have multiple dimensions. That is why we use NumPy array for multi-dimensional processing, specifically with related to image based processing, because image is nothing but it is a stack of RGB frame. The R, G and B stacked together is one particular image. So R is one dimension, G is the second dimension, B is the third dimension. All this together we put it into one, so that's RGB, right? So when we have those dimension based structure, it's very important that we go as list. So internally when you're processing a data in a machine learning algorithm, it's very important that we change it into array format and we use it for processing. So that's a key point that we all should ensure while we're deploying our data onto the machine learning model. So whereas list, it's just going to have an item and use some and use these items to point out to our storage, right? And another difference is, always the data is ordered in a NumPy array, but rather list, it's not like that. It's just arranged in a haphazard manner wherever locations are empty or vacant, right? At the implementation level, array essentially contains a single pointer to the contiguous block of data. And again, another important point is, related to the pointer.
Sandhya, there
Yes,
is a
sir.
question. What is a stride? It has been asked.
Strides.
Ah.
Okay, sir. Yes, sir. So strides is nothing but let us say we are having a two-dimensional data. So let's consider image data. I'm having an image of 256 cross 256, and we are doing some kind of filtering operations where I'll have a small window of 3 cross 3 size. So in my big 256 cross 256, in the top left corner, I'm going to keep 3 cross 3 small window. And what I'm doing, I'm moving the window one by one, and I'm coming and doing some operation on the small 3 cross 3 data. So out of the entire 256, I'm just processing the 3 cross 3. Now what I do, I move that 3 cross 3 window to the next position, or to the next element. From the 0th element, I move to the first element. From the first element, I move to the second. From second to third, and so on. This moving, right, we move with respect to one position. This is called stride. How many index positions I'm moving, that is called stride. So stride is of very much of importance when we are working with image based task, because in image based data science applications, most of the time we will be using a filter, or we'll be deploying some kind of sliding window task. So this task is called a sliding window. In sliding window, strides are very important to count after how many pixels my window has to be kept. When stride is 2, from 0th position, we will move the 3 cross 3 window directly to the second position. So we will skip 0 and 1, and I'll keep it in 2. So the stride here is 2. When my stride is 3, I'll skip 0, 1, 2 and keep the window directly onto 3. So this is strides. So, and we can do this kind of striding operation only on NumPy array. So when we are using this NumPy array for some database task operation, so the structure will also hold the strides when so how much number of strides it has to move the window while we're doing the real-time operation. So that goes with stride. Right. So at the implementation level, array essentially contains a single pointer to one continuous block of data. So there will be only one pointer when concerned with the internally how we are accessing the element. So ultimately, what is our motive? We are going to have some data in form of NumPy array, and I have to retrieve the data from the NumPy array, give it to the machine learning algorithm, and the algorithm has to learn the data and get useful insights out of it. So what it has to do, it has to access the data present in different positions, correct? For example, let's consider an image. We're having RGB column, RGB dimensions, so 3 dimensions, and let us consider we are having a height and width of 224 cross 224. So our given data is 224 cross 224 cross 3. So when I'm doing a CNN application, let us consider a convolution neural network. So what happens, I have to access my data from 0th pixel to 223rd pixel. So at that time, when I'm accessing this, it is more than enough if I have a single pointer to that first element, and from that pointer itself, I can get the complete block of data when we're having with array. But rather, in terms of list, on the other hand, contains a pointer to a block of pointer. So there will be one pointer that is pointing towards a block of pointer, each of which in turn points to a full Python object like a Python integer. So it's not directly pointing, but rather it first points to a group of pointer. From the group of pointer, it again points to something else. So what happens, the time duration for accessing the real element itself is delayed. We are having 2 cycles, right? 2 mission cycles will be delayed. So this is another reason why we use NumPy array for real time operations, because it's more faster than the list, right? So that's one reason. And again, the advantage of list is flexibility, because each list element is a full structure containing both data and information. So like we can even have a list of lists. It gives us more flexibility because it's a full structure. What we all know what a structure is, right? It's a heterogeneous data type. We can put lot amount of different data into one structure. So list gives us this feature, but whereas NumPy array does not give us this feature. So that is one upper hand where list gets onto it when we're having a heterogeneous data. But always ensure when we are getting the data onto the model, it always has to be onto the NumPy array format. Right. So again, the advantage of list is flexibility, because each list element is a full structure containing both data and type information. The list can be filled with the data of any desired type. Fixed type NumPy style arrays lack this flexibility. So as we discussed, a NumPy cannot be a heterogeneous data. It cannot hold on heterogeneous data. That is one upper hand that list has. So fixed type NumPy style array lack this flexibility but are much more efficient for storing and manipulating data. Right? So because NumPy are more efficient for storing and manipulating data, we have already seen what are the reasons for it. Right? So fixed type array in Python. So this is how we declare a fixed type array. So here below this we will find different ways of declaring an array in Python, how we do it. So one is we can first initially declare a list, and then we we change the list to an array. So Python offers several different options for storing the data in efficient or fixed type data buffers. The built-in array module available since Python 3.3 can be used to create a dense array of uniform type. So using this array module also, there's something called import array. We can get a NumPy array. Suppose this, when we are having a list, let us consider, I simply give np.array. So NumPy is imported as np, import NumPy as np, we all know that. So that is why we have NumPy. So NumPy.array of, inside my brackets I give a list. So as we all know, list is always distinguished with square brackets, tuple goes with the normal round braces, and dictionary goes with the flower braces. So here we find a list that's there with a square brace. I simply give NumPy.array of and we get a list out of it. Then similarly we have different options where we are able to give the data type, and then goes with NumPy array, and where we have a range along with a for loop. And sometimes we can also use Scratch. I just want to spend 2 or 3 minutes more here. When we are doing different data processing operations, it's very important that we declare some entities before our task itself. Let us consider when we are implementing a regression equation, y is equal to mx plus c. So y is my output that is going to have the value of m into x plus b. So instead of saving the value directly onto y during the real time, what we can do, we can initially declare the output shape of array. Let's consider we are going to get 10 cross 1. Our y output is going to be 10 cross 1. Using this creating arrays from scratch, right, we can initially create zeros of 10 cross 1, and every time we get the output, we can directly replace the corresponding output of y with the corresponding position. So using this kind of initialization task will help us prevent garbage values in our processing. So when we are implementing it step by step, it is always a good practice to initialize the output variable with the zeros or 1 array. So how do we do that? We do np.ones of depending on whether it is a multiplicative inverse or additive inverse, the task, we can use either np.1 or np.0. And like if I want to fill my array with a corresponding value with one particular value, we can also use 3.14 is the value that we are filling here. Let us consider I want to get the area of a square, pi r square, right? So in that case I want to multiply with 3.14. We can even initialize a complete array with one particular value, and we can create an array filled with linear sequence. If we can even have a sequence generated out of it, and create an array of evenly spaced value between 0 and 1. So we just have to make sure that we have a good understanding about how these different tasks work, because in implementing machine learning algorithms, each one will be used correspondingly. We have picked functions that all will be required for the remaining 4 days, right? In the remaining 4 days we are going to see different algorithms from machine learning. So all the basics that we are looking here is will be related to those tasks. So let's consider a line space, the line space task, right? In certain machine learning algorithms, after getting output, it is very important that we divide it into evenly spaced value. In those cases that we can use line space. Then randomly we always want some random distribution, right? Let us consider we are doing a neural network. In that case, we will be initializing the weight values. In certain case, we will be required to initialize a weight value with a multinomial distribution, or with a normal distribution, or with a Gaussian distribution. So in those cases, we can use this np.random to generate a random value based on our distribution required. For example, if we want to generate a random value of uniformly distributed data, we can use np.randomof, and when we want to distribute normal data, np.normal, and when we want to get a random integer in the corresponding interval, right? When we are initializing weights and all, it's very important that we declare it within 0 to 1, and similarly for other tasks also. In those cases, the limit can be specified using this function. And even identity matrix, we all know the importance of identity matrix when it comes with singular value decomposition and different matrix based operations. So in those cases, these initialization techniques will help us complete our task in an efficient manner. And similarly, empty array, right? So NumPy is data type. It initially goes with we have int 16, and these are the different data types that NumPy supports for us to do the task. So depending on the data that we're using, we go with float or int or even float 32 or 64 and so on. And similarly, complex operations too. Like for example, when we go with eigenvalue, and when we go with say Fourier transform based applications, our output would be a complex value, right? So in those cases, it automatically shifts onto the data, or we can move. NumPy gives us support to all those data types as we see here, right? So we'll quickly go to the next code. Yeah. Participants, kindly do open this notebook which goes with the name NumPy Basics 2, right?
Sandhya, is it possible within next 10 minutes are you able to do something to cover up? Because Sandhya,
Yes sir, because
is it possible to make it out by another 10 minutes? Because we have to take a small break. After that, we will be taking up the next section, which belongs to Suresh sir, which you know it already.
Yeah, sure.
Okay, so make out of that. However, the content and other thing we'll upload it. Participants, we request you that Sandhya, who is being here with us to taking up these classes now, will be having 2 or 3 more sessions, later stages, where she will be majorly concentrating on not only the basics, on neural networks, convolutional networks, and so on, which we have sent out the invitation in which you can look into it.
Yeah, so we'll quickly go through it. So coming to the basics of NumPy array, we have, as we saw, a NumPy array will always have a dimension. So it will have a shape, it will also have a data type. So like participants, whenever we encounter any error in Python, right, there's only like 2 basic solutions that will easily help us solve the error. One is print statement. Whenever you have any error, use print. The next statement is shape. So when we are working with machine learning algorithms, the shape is of primary importance. Always use this shape and size and data type to identify your error. So these are like the 3 important metrics we should always have a strong hold, and make sure that we have the corresponding data type and the corresponding shape that's required for a processing. So the NumPy array helps us have a good understanding of this. And then goes with the indexing. So we all know we just use square brackets with the corresponding index for the indexing task. Then goes with slicing. There are some necessities while implementing algorithm that we'll have to slice it, right? So in those slicing operations too, we use different colon format to do the slicing, correct? So like for example, when I give colon before 5, the first 5 elements will be done. When I give colon after 5, the next 5 elements will be done, and so on. We have a list of different ways of using the colon operation, right? Suppose this we have a multi-dimensional array. So this how multi-dimensional array will be 2 columns and 3 rows. So this slicing in multi-dimensional array and accessible. So when we're having a two-dimensional data, so the first row will be accessed in a similar format, colon and 0 and 0 and and in certain cases, like it's always
Sandhya, there is a voice break.
recommended that you make a
Sandhya?
copy of your
Sandhya?
data.
Sandhya, are you able to hear?
Right? So
Sandhya?
sometimes when we are working onto the data, you can use command to. Also, I'm able to hear you, sir. Are you able to hear me?
Because your voice is getting break.
Yes, I think it's minor bandwidth issues. Sometimes it drops and then it starts again.
Okay, fine. Please go.
Yeah. Yes. Then it goes with reshaping of arrays, right? And then we use these different tasks to reshape the array because it should always be in a format that our algorithm is able to accept. So that goes with reshaping the array, and then we go with array concatenation and splitting. So these are all like the basic syntax that we use for concatenating our array. And then so this is how it basically works, right? So we'll quickly walk through the next.
One,
So
Sandhya,
is it
one more.
time, sir?
One more. Yeah, that's better. I feel it. Now we'll take a small break. After
Yeah,
that,
sure, sir.
Suresh and the other section, while it is coming to your session in later stages, you
Yes,
can
sir.
make it out from this also. That's not the problem. So that you got 3 more sessions yet to come in these 5 days.
No, sir. Actually, the thing is, I'll be handling the next session. Like, so
Okay.
it's held up with the small work.
Okay, no problem, no problem.
So I'll be continuing, sir.
Okay. So,
Yes, sir.
Participants, shall we take a break now and we'll go for the next session? For time being, whatever the content Sandhya has made it out, we'll be recorded it and upload it accordingly. Then during the later sessions of Sandhya, she'll be making it out, whatever the things she has left it, accordingly she'll make an adjustments to take it up and make it out. So shall we take a break, please? Yes. So we thank Sandhya. Sandhya, are you in that line, please?
Yes, sir, I'm there, sir.
Yeah. So for time being, we'll take a break, Sandhya. Next, let us continue. After that, we will find it out in what way we will be able to accommodate it, whatever the things, because still a long way to go for you. When we looked upon it, only NumPy you have finished it. Still, does you cover this later things in later stages? You will be covering some other packages like Matplotlib and other things over there in your session.
Sir, actually, we have I mean, the content is prepared in such a way that, sir,
Okay.
we have a list of collab files for NumPy for
okay.
I mean,
that you are going to present.
And for the next one, that's Matplotlib. So we'll be sharing it with the participants. The collab files are self-explanatory. We are sharing it to them so that we cannot directly cover the entire content completely, but rather they can just have a look at it today or tomorrow post. And if they have any doubts when we are meeting in the session day after, they can contact us. So our ultimate thing is to give them a good understanding about what are the different ways Python is used for data science and the different syntax to help them identify where they go wrong. Okay, so many instances we have given like what are the possible error and how you overcome the error, right? So I'll just share the collab files with Dinesh sir now with regard to pandas and matplot, so we can just share it with the participants.
Yes, please. We'll do that. We will share it with the participants, please.
Sure,
thank
sir.
you.
If they have any doubt, if they have any doubts with regard to the chat content,
we will be taking it up
the day after, sir.
Yeah, that we will be taking it up soon, Sandhya. But thing here is, we thank you sincerely for your contributions now, because the reason here is actually your sessions is in the later stages. Since Padmanabhan is not available because of his personal happenings over there in his house, and Dr. T. Venkatabalaji is also not there because of the sudden demise of his brother. So at this juncture, when we called up during today morning, you have accepted and made us the things nice. Thank you a lot, Sandhya.
Thank you, sir. Thank you. Thank you. Thank you, participants.
Participants, you can take another 15 minutes break up. will be joining us by 11:35, so that we can start up with the Dr. Suresh, who will be with us to take up a little bit mathematics and again deeper into a Python codings and other things over there. So thanks a lot for all the participants being with us at this time. Thank you. We'll see you back by 11:35. Okay. So, participants are requested to join. I think morning we had around 170 to 119 participants. Now it is 92. We hope that all of them will be joining next within 2 or 3 minutes. See, as per the AICTE norms, which we have received it already, all those participants who have enrolled through AICTE through us. So those names only we have collected, and we have sent back the Google form. We have re-registered it again. We confirmed it because the maximum limit AICTE kept was 250. The later it was reduced. Later they forced us to limit it with 200 people. And in that 200 people, that 50 participants who have been in extra are being asked to inform that they will not be getting any certificates from AICTE in case we have enrolled it beyond 200. However, in the session of this machine learning for data science and analytics, such a problem is not there because all the participants are limited, and where already we have sent the Google form and you registered it. Therefore, we are able to have around 190 participants, in which 100 to 120 only is attending it over here. So in this case, there won't be such problems will be raised. But there are certain rules and norms as per the AICTE, we have to follow it. That is, we should have an 80% of attendance and 60% of the marks to be scored in the test. So what we will do here is, first time online test will be conducted for 25 questions, which we will be taking it up, and which will be conducted after the validatory functions within a period of 1 hour. You have to submit it. Those who submit it, we will be taking it up, evaluate it, and keep it ready so that related to the test part of as being mentioned by AICTE, it will be covered. The second part here is feedback. There is two things which we have to look into feedback here is, we are taking up a feedback for daily sessions because of our better improvement of a working. So therefore, we will be sending a feedback of every day to you all, in which you register it again, so that we will be able to consider those registered one feedback sent by the people as an attendance. And second part is, there is another feedback being provided by the AICTE at the end of 5th day. So that feedback also will be given to you, where you will be able to fill it up for the AICTE purpose, and we have to submit it. So there are two feedbacks which we are doing it. One is from our side on every day about all the 3 sessions, and second one here is AICTE feedback. And related to another feedback which we request all the participants here is, the last day where the validatory function is there, before that 10 minutes before, we need 3 or 4 people video feedback session, so that we will be able to understand of what we are doing. Then third part here is, all our daily sessions data, everything will be uploading it in the Google Drive, in which already you have enrolled it in the Gmail account. In Gmail account means it's a RKMVERI FDP@rmb.ac.in, where we got a Ramakrishna Mission Vidyalaya account, in which we'll be able to upload all our materials, so that it will be shared to you all, so that you can download it, keep it with you all, and you can use it for your own purposes. So these are all some of the things which we want to share it with you all now. Now, the next session starts. Before starting it, there's a small change over here. So Sandhya and Suresh, who are the both founders of your Passet Lab Image Labs, where they are doing a quite good number of projects, where they have an incubation center at Banariaman Institute of Technology, where they are playing a leading role in making up our students of data science. in developing a small projects related to convolutional networks and neural networks and so on. These two people plays a key roles in our academic part of Ramakrishna Mission Vivekananda Educational Research Institute. So since Suresh is having some meeting and attending his meeting, the Sandhya will be continuing your sessions over there, where she is good at mathematics also, where she will be talking about the linear algebra related to the application part of the data science in which she will be taking it. Of course, Dr. T. Venkata Balaji, who is assistant professor of mathematics of IIT Madras, who is being associated with me for a very long time. Since all of a sudden, the sudden demise of his brother has stopped him to participate in this event. However, we had a talk about it. He is also feeling to have one kind of a talk with you all during the last day of the session. That is on the 5th day, that is on 24th. He will be having at least 10 to 15 minutes of a talk with all the participants because he is very much eager to have it. So we will be having him with us later stages. Similarly, Dr. S. Padmanabhan, who is the CEO of Easy Design System, who has to take up this introduction to Python for data science, is also own uncle. His condition is critical. That's the reason he is not able to come in this session. However, he will be also talking for 15 minutes as a validatory sanction chief guest on 24th. So you'll be having both of them over here in our workshop also. So thank you all participants for a patient listening. Now, by 11:45, Sandhya will be coming to us to take up a mathematics part in data science, where she will be focusing more on a linear algebra and the application of linear algebra in data science, where they have applied a lot in image processing and what we call as NLP, natural language processing. Okay. Participants, I was a little bit fast. That was a comment which I have got it. If you have any queries, miss, please you can ask up with us. We unmute you so that any one of them can raise up the questions. Participants, you can, if you have any questions, you can put it in the chat box also, so that I'll be able to take up that question now. Okay. In that case, we'll be asking Sandhya, are you ready, please?
Sir, yes, sir.
Yeah. Just you can come inside. One second. Do you have to give both the feedbacks from Kalyani Angan? Yes, please. Please, we need a feedback from our own purposes for our Ramakrishna Mission Vivekananda Educational Research Institute purpose. We have to give a feedback of daily sessions because we are in the focus of evaluating about the speakers, and we are focused on more about what we call the quality in which the speakers, which we have to bring it and make it out. These are the things which we are trying to do it. That's the reason we need both the feedbacks. Please tell about the test part. See, test part is nothing but 25 questions. We will be giving it based on all the 14 sessions. So it will be, we'll make it out in such a way that whatever the content which we have presented it as a video recording once, from there only it will be coming up, where we'll be taking up the questions based on those things. Next question here is kindly concentrate more on maths portion than on a Python. Yes, sir, we will be trying to more concentrate on maths, which we will be looking at soon. Daily feedback link. We will be sending up the feedback link to your email ID so that you will be able to answer the feedback forms through a Google form. At the end of this day, please, not immediately. So at the end of the day, all the 3 sessions is a single form. Sandhya, you can take over.
Oh, thank you, sir. Um, Good morning, participants. So in this session, we'll just have a quick go through about the different linear algebra concepts that we'll be using in our machine learning model. Okay, so I'll be sharing the pandas list of collab files and matplot list of collab files by today afternoon, and you should be getting the related content possibly by before today evening. So with regard to that, if you have if any further clarifications are required, you can definitely reach out to us. So you can let Sridhar sir know, and we'll be able to help you out. Okay. So with regard to today's topic, and I'm sorry, we came to know about Padmanabhan sir's situation only today morning. So we happened to know about the scenario today morning. So we are we are using a PPT from one of the universities to get through the linear algebra concepts. And post this, we have a list of collab files which concerns about the implementation of ODE equations and using SymPy library in Python, ODE, partial ODE, and non-homogeneous equations, and so on. So we'll be sharing the files along with today's sessions. Okay, so kindly do bear with us. We were not able to get the PPT prepared in the short duration of time. So we'll just have a quick recap of linear algebra concepts here, and in-depth explanation of the different mathematical concepts with regard to this we'll be handling in the forthcoming sessions on day after tomorrow, right? The day after tomorrow. So we'll have in-depth mathematical analysis there. You can feel free to ask us then. Okay, so coming to mathematics for machine learning itself, right? So apart from linear algebra, as the today, I mean, the entire theme is focused on like mathematics for machine learning. Like as all of us know, max has different way of analysis. Like we have linear algebra, we have calculus, we have and we have statistics, we have probability. So and we have numerous other graph theory and so on. That's with mathematics. With regard to machine learning, so we can say that four major topics in mathematics plays a very important role in machine learning. Let's consider a simple equation of y is equal to mx plus c, y mx plus b. All of us know about y is equal to mx plus b, right? So we have it in we have it for simple linear regression, starting from simple linear regression till we go till the final say neural network implementation too. So if you consider y is equal to mx plus b, so we have to calculate the slope, or then we have to do a kind of multiplication. Post the multiplication, we have to find the slope of the angle. So when you look at the entire implementation of the equation itself on algorithm part, we have the linear algebra coming into it for the matrix multiplication, a slope part which comes around with the differential calculus, and then probability comes with in the other part of implementation, and so on. So on a wider part, on a wider scale, we can say that it's not only one particular mathematical domain that is responsible for for implementing a machine learning algorithm, but rather it's a combinational effect of different mathematical techniques for implementing a single algorithm itself. So here what we are seeing is one particular stream of mathematics, that's linear algebra, right? So all of us are familiar with the term algebra from the school, and we've also been through linear algebra in our undergraduation and so on. As we all know, matrix, special type of matrix, inverse matrix, determinant matrix, statistical application matrix, transform systems, systems of linear equation, linear systems, and inverses and references, and so on, right? So like when we say about matrix, the primary kind of mapping that we do to matrix and data science is image, right? So as we all know, what is an image? An image is a two-dimensional data, right? And on a even an in-depth explanation, we say that it is a multi-dimensional data because we're having three dimensions, R, G, B. right? So all this together. So whatever applications that we're seeing, right, the mathematical operations, I'm be trying to give you a direct on interpretation with related to image more, because images are basically a two-dimensional data. So I'll try to interpret more of that, and also I'll just try to give you a intro, or I'll try to give you an interpretation of what each mathematical part does to the data. So if I take a mean, what happens? If I take a median, what happens? So that's what I'll try to help you out with this session. Post this, we'll go with the implementation of SymPy with I mean with the ordinary differential equations through Python, right? So as we all know, what is a matrix? So a matrix is m cross n structure that has different elements present into the corresponding locations, right? So the thing with matrix is that the m and n can be different, right? So when m is equal to n, we call it to be a square matrix. Fine. So coming to matrix addition. So what addition does onto data? So primarily we all know any algorithm that we have some kind of addition happening into it. Let's say y is equal to mx plus b. So even there, I multiply my m and x. I'm going to add with my the other component b. So what I'll like to share with you here is the major application of linear algebra or mathematical concept is how I'm able to apply that addition operation in the most effective manner. For example, we all know a square, right? The square of a matrix. Let's consider y is equal to a square. So we are, what's the regular thing that we'll do in our say in our schooling days, or like what have we are exposed to? I take my a matrix, and I multiply the two. And we know the kind of operations that is involved in a matrix multiplication, right? We take every row, we take every column, and we're going to multiply them individually, right? So it's like it consumes a huge amount of time duration, and lot of mission cycle is required. Along with that, lot of buffer memory is required in between, because we'll have to store the individual values, right? So what happens, this consumes memory and this consumes time, both is there. So the simple thing can be also implemented as A inverse into A transpose. So using the properties of the matrix A square can also be given in another form, that is A into A transpose. So when we're doing that, we are able to minimize the computation that's required for the corresponding operation to be implemented. So what I perspective, or what I on my personal opinion feel, that a wide range of linear algebra and its applications is used on minimizing the computation cost and effectively implementing the different techniques or the different equations onto the real time, and for for the quick processing of the data. And then going with matrix addition, so we all know what's addition and what it does onto it. So here it's like the simple a plus b, and then it goes with the scalar multiplication and then transpose of the matrix. So we're all familiar with what are these basic concepts to do with. And then coming to the diagonal matrix. So this diagonal matrix plays a very important role, more specifically when we're concerned with the singular value decomposition, and also when we do the other kind of decomposition task, right? So in those cases, the diagonal values itself plays a very important role, and the leading diagonal on a wider perspective, right? So even like say when we have CNN and deep learning based applications, the length of the diagonal and the width of the diagonal is very important when we do a lot of operations. So in those cases, diagonal matrix can be exploited to get out the most effective elements present in a given matrix. And identity matrix, so we're all familiar. So identity matrix is a diagonal matrix with the diagonal elements to be equal to 1, and it is most often widely used as additive inverse or like multiplicative inverse in a given equations. Then coming to the upper triangular matrix, and then coming to the lower triangular matrix. So a well-known applications of this upper triangular and the lower triangular component is what one of the wide known application goes with feature selection, right? So when we have a huge amount of data, it's very important that we reduce the redundant data. We remove the redundant data, and we do the and we filter out our most potential information, so that we reduce the we reduce the total weight of the model, and we get the most effective and most potential information. So in such case, what we do, let's consider a simple example. There's a technique called MRMR, for feature selection. So one application of upper triangular matrix is in MRMR. So let's consider I'm getting a square matrix, and every element in the matrix is the value of correlation between my first feature and my first feature. So when we have a matrix like that, so what happens, we get a structure in such a way that the most important features are present onto the upper triangular matrix of it. So what happens, it's more than enough if we are processing the upper triangular matrix than the entire matrix itself. So in such cases, with regard to feature selection, with regard to feature engineering, these basic operations helps us get a better grasp of what is the hidden pattern present in the data. And similarly with lower triangular matrix and symmetric matrix and skew symmetric matrix. So we all know what a symmetric matrix is, right? So A transpose is equal to A. So we simply see what a symmetric matrix in terms of, say, property. Whenever the transpose of a matrix is equal to the matrix itself, we call it a symmetric matrix. But this symmetrical matrix plays a very important role with regard to weight initialization of neurons. So we all know neural network is a very predominant algorithm in machine learning. So there, the convergence of the network completely depends on the initialization of weight. So when the weights are more effectively initialized, the algorithm is able to converge very quickly. So the training time reduces and it's able to reach its minima point, and the error gets reduced. In such cases, it's always with regard to CNN specifically, with regard to convolutional network, we have an analysis says that whenever the filters are initialized as a combination of symmetric and unsymmetric, the network is able to converge faster, right? So in those cases, with regard to initialization of filters in a network, the symmetric property of the matrix plays a very important role. So and it can also be in regular image processing based task, where we have a symmetric window, where we have a non-symmetric window, and the different symmetric and non-symmetric window plays um, different kind of operations onto the data itself. So this is one application of the symmetric matrix in a real-time way, and very specifically with regard to filter initialization in a CNN network. And coming to skew symmetric matrix, so this is again a matrix with A transpose is equal to a minus A, and again, wherever we are having a window, a filter, or when we are having a matrix, say some other way, like say we have got HOG features, or we've got some other features from the image, there this skew matrix plays another important role, like how symmetric matrix does. And coming to inner product, so we all know what an inner product is, right? So A into B.
Sandhya, there is a
Yes,
question.
sir.
There's a question that Euclidean distance matrix
Yes,
is
sir.
a upper/lower triangular matrix in clustering.
Okay.
That is being questioned by Ashish Zabri, who has put up this question called as a Euclidean distance matrix. Is also a need, that is it a triangular and upper triangular and lower triangular matrix in clustering, whether we are able to use Euclidean distance matrix?
Euclidean distance matrix is also upper lower triangular matrix in clustering. So like, is it a question, or like, so is it a statement that that we are, I mean, like, that you're trying to tell? I just have a small clarification.
Okay, statement.
Yeah,
Yeah.
thank you. Euclidean distance matrix of, yes, of course. Another application is Euclidean distance. So thank you for yes. Like this distant matrix plays a very important in the technique called KNN. So we are all familiar. I mean, like, we've heard about KNN, right? The nearest neighbor. So where the distance plays a very important role, and similarly in clustering. So where based on the distance, we like simple K means clustering, where we cluster it based on the distance, right? So in those cases also, like, the data comes in terms of a matrix, and this upper triangular and lower triangular plays an important role in those scenarios also. So A into B. So like, we don't find a single machine learning algorithm without the implementation of A into B, right? Starting from a simple regression to say any complex thing, everywhere there's an inner product. But what linear algebra comes into picture, or like where it comes into picture, is like how the inner product operation basically happens. So for example, let's take a convolution operations. Let's take a basic image filtering operation, where I have a low pass filter and a high pass filter to be applied onto image. So what do? I take a small low pass filter of 3 cross 3, I slide it across my window, of the image, and I get the corresponding output, right? So what do internally what convolution does? Convolution is nothing but a repeated multiplication combined with the addition. So we do a kind of dot product based multiplication followed by a addition in terms of directly, I mean, when we do mathematically hand calculated. But internally, if we look the way, let's say, Keras framework itself, right? So the way Keras framework handles the data is completely different. So what happens, it once we get the 3x3 kernel, instead of having the data as such in a 3x3 kernel, it just flattens it. So from 3x3 it changes into 1x9, and the image, let's consider it's 32x32. So from 32x32 it just flattens it into some other a 1D data, and then the operation happens, and then the inner product operation happens. So why does the framework internally does this kind of happening? So it does this to ensure that the computation is executed at a faster rate than the regular than doing it in the spatial based multiplication. So like these are like basic applications where inner product is used, and similarly with regard to y is equal to mx plus b2, so where we multiply the slope along with the x component. So they also the algorithms are designed in such a way that we get to multiply it effectively, right? And next goes with matrix multiplication. So we're all familiar what a matrix multiplication does and where it happens, and it's definitely used in huge amount of applications. So like these are all the different algebraic properties which we have already seen, right? We are already familiar with the computative property, the edit, then it goes with the distributive property and so on. Like each different property is used in each different scenario in different machine learning models, right? Again, so where every property is used is we'll see in depth in our forthcoming sessions. And coming to non-singular matrix, inverse matrix, and invertible matrix, like these matrix, this kind of checking, right, it plays a very important role with regard to PCA based applications, right? So what do we do in PCA? We just reduce the dimensions, total dimension of our input data. In such cases, like before we even decompose the matrix or before we even do any applications, we first have to ensure that the determinant does not vanish. So the determinant exists to make sure that the decomposition actually happens. In such case, what do we do? The first check that we do is to check whether the matrix is invertible or not, right? So in those applications, so these different properties happen to be different check marks or different checkpoints. Like once the first checkpoint is done, we go to the next implementation. The next checkpoint is done, we go to the next implementation, so on. So these properties help us in ensuring that a model works more effectively, right? And associated with every square matrix A is called a determinant, and like all of us know what a determinant is, right? So with every square matrix we're getting a determinant, and with every determinant we have two more values always coming with a determinant. One is the trace of a determinant, and the other one is the trace is nothing but the value of the leading diagonal elements, and the determinant value of the determinant itself. So that's what we get the determinant output. And one big application of the trace and the determinant comes with the eigen decomposition. So we all are familiar about eigen. So definitely when we speak about linear algebra, it's a big injustice that we do if you don't talk about eigenvalue, right? So what's basically an eigen? An eigenvalue is the unique value present in a matrix that has the highest potential information, right? And so let's consider I have a wooden box. Okay, let's consider it's a flexible box, and to that flexible box I'm exerting a pressure, and that pressure I give it in a horizontal direction. So what happens when there is a pressure happening onto the system, in considering it in a coordinate system? So let's consider the box is present on a coordinate system, and I'm giving a force onto it, and the object itself will be undergoing a change, correct? And within the object there will be certain vectors that did not undergo a change. Let us consider I'm having a cylindrical, and my object is a cylindrical structure. In the cylindrical structure, when I'm giving it when I'm giving it a pressure on the horizontal direction, what happens? My height component, my diagonal component will undergo a small change because of my external pressure, but rather my bottom component, which is my base, will not undergo a change. My base will still be rugged, right? The direction, it will not undergo any particular change of its position, but rather it remains rugged. Only my height component and my diagonal component, and the overall surface area will undergo a change. So let us consider we are mapping the cylindrical value to a vector space. Fine. My height is a vector, my diagonal is a vector, my surface area is a vector, and my bottom is a vector. So when we see this vector space, when there was an external pressure, we analyze that the bottom vector do not have any particular do not undergo any particular variation. It remained constant, correct? So this bottom, the vector that corresponds to the base is called the eigenvector, because this eigenvector do not undergo any change with respect to the external pressure, or when the system is exposed to a change. So this constant vector is called the eigenvector. And let's consider I'm giving it a push. So when I'm giving it a push, what happens? It might have a slight variation, right? It can either go say little, the direction of the vector will not change, that is the base will still remain base, but rather the magnitude alone will change, correct? So let's consider from 0.5 centimeter it moved to 0.9 centimeters. So there's only a magnitude variation, but rather the vector remains the same. So this vector that did not undergo any variation is called the eigenvector, and the magnitude with which the variation happened is called the eigenvalue. So this eigenvalue and this eigenvector plays a very important role in our PCA and in numerous machine learning applications to identify the most potential vector space in our given environment. So what happens if I'm going to take my eigen vector and my eigenvalue of a given matrix? Let's consider I'm representing my system of equations, or I'm representing my input data into a matrix, and when I'm going to take my eigenvalue and when I'm going to take my eigenvector, it's going to tell the most prominent and the most potential feature information present in the given environment. So in another case, this eigenvalue also plays an important role in terms of decision tree, getting out the feature that has the highest or the richest information present in our given environment. So coming back, so if I is the identity, then determinant of I is 1. So we know about the identity value. I mean the determinant of the matrix, and similarly it goes with interchanging what happens when I interchange the row and column, and what happens when two determinants have the same value, and what happens when I multiply a scalar matrix. So a determinant of P is equal to M determinant of A, and determinant of the lower or the upper triangular matrix is always equal to the product of its diagonal entries. Right?
Sandhya, is
So,
it possible, that is Sandhya,
yes, sir.
is it
Yes, sir.
possible to have some kind of a coding related to this and show them? Because some people are asking for example part, if you can show, there will be better understanding on it.
Yes, sir. Sure, sir. Sure.
If we arrive that, you can share with them. You can at least display it and run it or show that content.
Sir, yes, sir. Actually, day after session, I mean, day after tomorrow, we're having a session on the dimensionality reduction part, sir.
Okay.
So in that, we'll be having a in-depth explanation with regard to how we use this concept, sir.
Okay, fine. Thank you. That's all.
Yeah.
Thank you.
And can you please illustrate with an example with regard to what? I mean,
that is
which
what the
particular
talk,
concept?
what the talk you have been having it now. Recently, you have been talking about that matrices and determinants. In the determinants part,
Yes, sir.
how does you apply it? That is being the question. During that time, only the question came. Like all
Okay,
in
okay.
matrix.
So yeah, so I can just tell one basic example, sir. So let us consider we are having a
no,
we
what is there like a coding part, running that coding part?
okay with related to coding. Yeah. Sure, sir. Sure.
If you have it with you. If you have that collab file or a direct file also, you can run it or shoot it.
Yes, sir. Yes, sir. Yes. So is my screen visible?
No.
We should have a collab file.
Yeah.
With eigenvalue and eigenvector.
No file is viewing, please. Just you are this file only is able to be viewed. Yeah.
Okay, sir. Okay.
Just try.
Now?
Yeah, one second. Yes, we are able to view it.
Yeah.
Yes.
Yeah. Yeah. Okay. So this is the list of series that we'll be sharing today with regard to linear algebra. So whatever the concepts that we have discussed now, we have the implementation part here, right? With regard to starting with yeah. So starting with ordinary differential equation. So the first file goes with how we implement ODE equation. How do we solve them without with SciPy library, with the SciPy library, and we use this derivative. So we have actually included this ordinary differential equations because like most of the machine learning algorithms, we do some kind of optimization, right? So our ultimate target is to make the model come to the minimum error. So in that case, the one predominant algorithm that we cannot remove is backpropagation, and backpropagation works on gradient descent. So gradient descent again works with gradient. So to help us have a better hold, or to have us a better understanding of how ODE equations are solved in Python, we have given the first two slides of how solving ODE equations using SymPy. So I'm just sharing it so that so that they can have a self-learn kind of thing, because it's quite simple, right? We'll quickly go to the next. Yeah. So the next slide also deals with implementing of ODE equations. I mean the next collab file, and here we are solving it with respect to a damper system. Okay, we are solving ordinary differential equations with respect to damper system. We have a damper system represented, and we are solving it with respect to we are solving this with using the SymPy library, and how the derivative is called here, and how it is implemented, how we are exactly calling this d square y by dx square plus 2 dy by dx minus 3y. And this file concerns with the implementation of the ordinary differential equations, right? So here we'll be using the library called SymPy. So that's used for our applications with regard to ODE. The third one The third one goes with non-homogeneous second order ODE equations. So as we all know, we have different kind of ODE equations, and different one require different solving. And here we are concerned with the non-homogeneous equations. And similarly, we're having a damper system taken here for consideration. And in the damper system, we have the equation that has to be solved, and we are using the ODE to solve this equation again. So the next one goes with the ordinary differential equation extension. So how we are having how we are going with the general method for the ODE data, and the fourth collab file goes with the implementation of that. So we can just have a quick look once I share this file in the afternoon. And coming back to our interest, and again we have some ODE related content here. Yeah. This goes with the equation of ellipse, and solving them with regard to tangent line, and similarly. So this tangent line plays helps us have a better grasp with regard to slope. Like as we all know, when what do we do in a linear regression, we are trying to fit a line onto the data that's distributed. In those cases, the slope of the data is very important. Their slope is nothing but, as we all know, it's a tangent. So we've just given some workout models here for us to have a better understanding about the tangent part of it. And coming to our interest here, that's matrices and operations, right? So we are implementing all our functions with respect to NumPy, right? So as we all know, what is a vector has two dimensions. That's it has a magnitude and as a direction. So here, any any data with more than one element present in it, we consider it to be a vector here in NumPy. So a simple vector can be given as a NumPy array of u and v, and we create a matrix out of it, right? So we just arrange different vectors to form a matrix out of it. So this is a basic way of how we create a matrix, followed by the dot product vector matrix vector multiplication and taking the response. So as we all know, we just use the numpy functions dot product to take the different ways. So this how we implement it in terms of Python. The product a into a transpose, a into a and au and so on, and this goes with getting the determinant and computing the inverse. So these two functions are very important with regard to the forthcoming applications, like when we do dimensionality reduction or when we do some other machine learning models. We'll use this inverse and determinant checking more widely. And then coming to transformations. So we can examine the effect of multiplying a vector by a matrix and visualizing the transformation of a cube. So we just see when we multiply two different dimensions, like what happens here in this particular matrix. So participants, I'm really sorry, like we came to know about the session handling only post 7:30, so we were not able to get content more effectively for you. If we had known it, like say little before, we actually would have delivered it in a better manner. This short duration is like helping us rush up more. I'm sorry for the inconvenience caused. You can definitely get back to us in the forthcoming sessions day after tomorrow for the in-depth explanations with regard to it. Okay. So then it goes with the diagonal form of it, and then the determinant, and how a variation happens when we multiply a small a 2D, I mean two different elements of two different dimension space, right? And then we get the transformation matrix and the determinant part of it. So how it happens internally, right? And then we have the visualization part of it. So this goes with here. And coming to orthogonal matrices, so we all know orthogonality, how important role it plays with regard to singular value decomposition and with regard to numerous other machine learning techniques too, right? So this particular collab file will help us have a better understanding about how this orthogonality check comes into here, right? So initially we just import the numpy, we create a matrix with 4 random entries, and we use QR factorization of A to create an orthogonal matrix, right? So we use, as we all know, to create an orthogonal matrix, we have to do some kind of factorization technique. So here we use this QR factorization technique to get out the orthogonal matrix of it. And we verify, so as we all know, the property of orthogonal matrix is to, like say, q inverse is equal to q transpose, and we use this particular operation to check if the corresponding conditionality has been reached to determine if a matrix is orthogonal or not. So this basic checking, we're just giving you the corresponding codes, I mean the corresponding syntax for you here, so that when you require these steps in machine learning algorithms, you can just take it there and implement it here. Right? So let's consider we are developing a novel machine learning technique to check if a given particular feature set has orthogonality in it or not. So in those cases, like we hope this helps you do your implementation part in a better, effective manner, right? So then goes with the numerical precision. So we see even in a more precise manner how much is the difference that's happening. Then the columns of Q are orthonormal, and QT is also a rotation matrix and orthonormal columns, and therefore the rows of Q are also orthonormal. So with regard to the given matrix, we identify what is the rotational matrix going on and what are the orthonormal columns present in our given data.
Sandhya, there is a question that is there any difference between orthogonal and orthonormal?
Yes, sir. Yes, there's like a very both are like two different streams. So one is orthogonal and the other one is orthonormal. So orthogonal is nothing but, generally what do we say orthogonal? Anything that's perpendicular comes under a orthogonal. But orthonormal adds even more properties onto the given data. So orthogonal part concerns with, let's say I'm having two matrices. I want to know if the two matrices are perpendicular to each other. So in that case, I go for the orthogonal one. And the orthonormal is having a unit amplitude, like as Kalyani says, right? both are different, and both are different streams, right? So coming to vectors and biases. So all of us are familiar with the term bias. We have come across in a numerical, I mean, in numerous machine learning algorithms. We say bias. We say bias like uh, on my simple terms, like one simple way I always interpret bias is, we always say in a classroom that the teacher is always biased to one particular person, correct? Say we say that the person to be a pet of the teacher and so on. I see bias in a machine learning model similar to that. So what bias basically does is, when I have a group of data, bias helps me figure out the most important component present in the data that is required for giving out the that's required for giving us the required output, say giving the prediction a better manner. If I'm having a group of data, one particular component will be highly potential, will be even rich than the other ones. So it's important that I give more bias to that particular component. So bias is again a trainable component present in different machine learning models, either be it like neural network, or either be it regression. In all those cases, we have a bias to give stress, to give more importance on one particular feature, right? So that comes with bias. So it's again an additional trainable component, similar to weights or similar to other trainable parameters or coefficients that we have in our in our corresponding algorithm. So that comes with bias. Whereas here we talk about bases. So a base is it's again a very wide area in machine learning with regard to linear algebra, because we each particular system behaves in a different manner when we are treating it in different bases. For example, I have a system. It's basically a system of equations. I have three different equations. I get a matrix out of it. So this is the normal matrix space. When I take the eigenvalue of it, and there's an with regard to eigenvalue, we have another space called eigenspace, correct? So the same system of equations, when I transform it to eigenspace, and when I look at the values present in there, it gives a completely different interpretations. For example, a value of correlation in a normal space will give us a different interpretation, but rather when I take the same correlation in an eigenspace, the kind of interpretation it gives will be an entirely different value, will be an entirely different space. So this is the kind of a change that we have when we transform our system from the given space to another basis space. So basically the basis can be eigen basis, or it can be a cosine basis, like when we take the DCT, or when I take DFT, and so on. So what happened, from one base system I change my system to another base system using different kind of transformation techniques, and the behavior of the system completely varies from one platform to the other platform. Just a minute. So for example, we are all familiar with covariance matrix, right? So what is a covariance matrix? It tells the variation or the variance that's happening in my given system of equations. When I take a covariance matrix for my normal system of equations, it gives us a different interpretation. But rather, let's consider I shift my basis function to my eigenbasis value. And when I take my covariance matrix there, what this covariance matrix in the eigensystem does is, it helps us identify the principal lines of force or the axis of greatest variance. So as data scientists, variance plays a very important role, right? We always are very concerned about the variance and the bias trade-off, and this variance is a key important factor that we can never eradicate out of machine learning. So in such cases, what happens, the covariance matrix is helping us identify the greatest axis of variance just by transforming my given space to my eigenspace. It's a small example, and similarly it goes with the different examples too. And let's consider the Fourier transform. So I have my given system of equations. I take my DFT to shift it to my Fourier basis. So when I'm going to take my Fourier basis, and with regard to image, right, so it helps us very cleanly identify the frequency variations in a given image. So these frequency variations will help us very precisely determine the edges present in an image with regard to edge detection applications. So more specifically with regard to medical applications, when we have to find out the tumor, or when we have to identify the lung cancer based, even like we COVID, right? There was a lot of research going on for diagnosis of COVID using chest X-ray. So in those cases, what happens? I have to identify a very small minor variation present in my lung because of the COVID infection. So in such case, what happens? There will be a very feeble variation of my pixel intensity. So this pixel intensity, I call it a frequency variation, which can hardly be identified or spotted easily in my normal basis. So from that, we shift to the Fourier basis, and that's the DFT. We take the DFT transform for the given image, and in that we are exactly able to figure out where the pixel variation happens. That is nothing but a frequency variation. So variation in pixel intensity is what we call frequency variation in image processing. So whenever that frequency variation can be spotted out more effectively in my Fourier basis. So like it's very important that we try to have a better grasp of what each data, what each space does onto our data, like a DCT or DFT or another big space or another big basis is wavelet. So most of us are familiar with it, right? So the decomposition of my given image into different resolutions. Like we see the image in a single resolution, but when we decompose the image into different resolution, into different different levels, LL, HL, HH, and LH. So when I'm going to decompose the image into different frequency components, we are able to obtain different texture informations, correct? So those texture informations that we obtain at different levels cannot be directly seen in my original space. So this is the kind of effect that we have, or that we apply in machine learning techniques with regard to real-time data, and more specifically with regard to our image processing base. The same applies with the other kind of signal processing also, considering the audio based. Yes.
Sandhya, there is a question. What
Yes.
factors we need to consider for selection of a bias value in neural network?
Okay, so bias value. So basically, bias is a trainable parameter, like a weights. So as we all know, weights is a trainable parameter, correct? So bias is also a trainable parameter. We just have to initialize a bias and get it into, develop a model with bias into it, and the algorithm will be able to determine itself what to which particular feature that it has to give a higher bias with regard to training. So the bias, it's not basically a bias value, but it's about having a data set that has a variance bias trade-off. So this bias comes into picture with regard to the collection of data set. So the bias and the variance component that we see in algorithms is more related to the kind of data set that we collect, how my data set is distributed, whether it's, let's consider I want to classify red color t-shirt and a blue color t-shirt. So, and if I'm going to have more, say 70 images of red color t-shirt and 30 images of blue color t-shirt, my data set is biased and the performance will vary. So that's the kind of effect we have. So basically bias is a trainable parameter. We are not giving a value onto it. We only initialize a bias with some metric, and the algorithm after training itself will set the bias value. So what we can do is we can see how the bias value has varied. So let's consider initially I set my bias to 0.1 and I allow my algorithm to train for 50 epochs. So 50 iterations, let's consider a neural network. After the 50 epochs, we see from 0.1 how much my bias has been changed, right? So whether it's gone to a positive bias or whether it's come to a negative bias. So we can, using that, we can identify to which particular feature my algorithm, because neural network itself is a black box, right? So as we all know. So with the value of bias, we'll be able to interpret in a better manner to which feature my algorithm is giving a higher importance than the other features. So that's about bias. So basically, it's the bias variance trade-off. It's itself a in-depth topic that we most often relate, or like that comes hand in hand with underfitting and overfitting of a network. So as we all know, for a model to classify well or a model to perform well or a required application, it's very important that the model has a best fit. It should not be overfitted so that it just memorizes the feature and it is not able to perform well to our unseen test samples. When I give a real-time test sample that was not present in my training data, in that time also the model should be able to perform well, right? So in that case, what happens, the model should not be overfitted but rather fitted correctly. That we call it as generalization. We have another error called generalization error. We are all familiar with test error, we are all familiar with training error, but another important error that we'll have to consider is a generalization error. So this error will help us identify how generalized a given model is, right? So a bias comes into picture in that regard, variance bias trade-off, and to the overfitting and underfitting of the model, right? Yeah, thank you, sir. So with regard to basis, so we were talking about the wavelet basis. So wavelet, as we all know, like what it does, it's basically decomposing a given data into the different things. So that was with regard to image. The same goes with any kind of signal processing base. So let's consider speech signal. So that's a widely used, widely used. I mean, now currently booming technique, because we get a lot amount of data with regard to the speech-based applications. Every home is having a Alexa, every car is having a Alexa, and every one of us use OK Google, right? So now currently we have lot amount of speech data put into our network with the kind of YouTube videos that's getting streamed. So in again, analyzing my data directly in the given space, rather than that, short term Fourier transform, right? So the discrete short term Fourier transform is another widely used basis function that's used for analyzing our speech signals. So basically, on a even wider perspective, we see that this kind of basis and this kind of operation comes onto a signal processing level, right? So because, as we all know, all the data that we get in real time is a signal. So image is nothing but a two-dimensional signal, but rather our voice is a one-dimensional signal, right? So it's more of like understanding what happens to a signal when I'm going to do different kind of transformation and to different kind of basis. So that concerns with our vector and basis, right? So next, coming to coordinates and to our rotations. So this about what are the different coordinate system we have, and this about the rotation components with regard to that. And then coming to the implementation of eigenvalue. So we compute the eigenvector to get the orthonormal vector and verify the eigenvectors are orthogonal, and it goes with the implementation of eigenvectors and eigen orthonormal. So actually, participants, it was like a very short notice. Otherwise, we have a in-depth thing about how this eigenvector affects the feature selection. So like now we have deep learning based technique, but for machine learning, feature engineering is the biggest task. So that's what machine learning comes. And in machine learning, feature selection eigenvalue is like most widely used feature extraction, right? So we do have a separate content with, I mean, we have a separate content with regard to that, but due to short duration we couldn't just gather it out. So if possible, in the forthcoming sessions we'll try to have a in-depth explanation with regard to that. And next, going with eigenvalue and eigenvector. So as we all know, there's a basic equation that goes ax is equal to lambda into x, where lambda is the eigenvalue and x is the eigenvector. So my given system of equation, it gets multiplied with some vector, and that is equal to my lambda, that's my the eigenvalue, the magnitude, times the given x. So we solve it, and that's like, these are the basic steps that we go, that we're already familiar with. And this goes with the implementation of eigenvectors, so as we all know, to compute it. And this is the kind of symmetric matrix that we discussed, so detecting if a given matrix is symmetric or not. And we've also seen about the applications, and also with regard to non-symmetric matrices. Yeah. So coming to diagnosing, so yes, most of us are familiar about the kind of SVD, the singular value decomposition, and how much it's been used for different tasks, right? The U, V, W, and it has a widespread applications, and it's like, it's a vast domain. And in that case, this diagonalization of linear algebra is the key factor that is enabling us to split the U, V, W components. Only because of diagonalization we are able to get the orthogonal, orthonormal, and the different components. And we know how it's used, like for compression based techniques and for different techniques, how these are used, right? And it goes with diagonalization of symmetric matrices. So like, these are the basic equations. We'll have a view of it when we are looking at the forthcoming topics, right? So this is about the symmetric matrix and about the eigenvalue based things, and it's about the power iteration. We demonstrate a case where power iteration fails, namely starting vectors orthogonal and the eigenvector associated with the largest eigenvalue, and we compute the starting vectors orthogonal to the eigenvector associated with the largest eigenvector, then perform the power operations, right? So that's about eigenvalue, and that's about eigenvector, right? And finally, we go with the applications of eigenvalue problems. I think we've spoke a lot about eigenvalue, and the other important concept is rank with regard to linear algebra. So basically, rank tells us about mathematically what rank means is it tells about the number of rows with non-zero elements. So how many elements are present in a given system of equations in a given data activity. So similarly, this rank plays a very important role with regard to feature selection in our machine learning models, where we are able to spot out or we're able to tell the system of equation of what rank it is, right? So that's another important application of linear algebra onto system of equations. So I think that's with rank. So any questions from the participants? Any questions? Any questions? Application of rank, yes. Application of in PCA principal component refer to one single attribute or a combination of attributes. A principal component refer to one single. Basically, in PCA, it's like reducing the dimensionality. About I have a given system of features extracted that has 50. Say it's like it has 50 dimensions. One particular example is related to hyperspectral data. So in hyperspectral data we get a huge amount of dimensions, right? So in that case we are just trying to reduce the dimensions with regard to lesser dimensions. In that case we use PCA to reduce the dimensionality of the given data. Day after tomorrow session we have dimensionality reduction into it, and we'll have a more in-depth explanation of how PCA works. So multicollinearity rank. Can you explain eigenvector, eigenmatrix, eigenvalue, and its significance to physical system? Yes. So just a minute. I'll try to open a document that we have with regard to eigenvector. So there should be a window here with respect which shows shear mapping. I just want to have a quick check. So is there a window that shows shear mapping?
Yes, please.
Yes. So with regard to eigenvalue, so let's consider I have a system as given here, x and y, that's v1 and v2, and let's consider we are applying some real time pressure onto the system. So this pressure can be shear mapping. So shear mapping is nothing but some external force that we are giving onto the system. So what happens when I'm applying this force onto the system of vectors? We can see that the vector v1 has undergone a change because of the shear mapping, because of the push that we have given onto the system. So from this particular direction, the vector has tilted to a direction, but rather the red color arrow remains constant. It's not undergone any variation. So this particular vector, which did not undergo any variation due to our external force or due to the external pressure that was given, is called the eigenvector, right? And if we even look at a clear in-depth manner, we see that the vector is elongated. The vector has been stretched by with respect to a magnitude, right? So let's consider initially it was 5 centimeters, and after the shear mapping from 5 it had moved to, let's consider, 7 or 8. So this magnitude with respect to which my eigenvector elongated or stretched, basically it's kind of magnitude variation that happens, right? So this magnitude variation is called the eigenvalue. The magnitude is the eigenvalue, and the vector that did not undergo any variation is called the eigenvector, right? So am I answering to your question, sir? Am I answering to your question, sir?
Yes,
Yes.
Shiva Govindasamy has asked it, and you have put it over there.
Yeah.
There.
So, and with regard to yeah, in which scenario do we go for shear mapping? So I've actually
the
mapped.
page ranking will go the last collab file you have run it.
Yes, sir.
And that one you can go by step to explain it further.
Which ones?
Yeah, once again, there is a question from Jagadishwari related to the scenario. In which scenario do we go for a shear mapping?
Okay, so basically, ma'am, shear mapping I put it because to help us understand in a mechanical manner, like because eigenvalue originally evolved from mechanics. So initially, eigenvalue was proposed with regard to mechanical systems, because generally mechanical system are exposed to pressure, right? In that case, we go for mechanical system. On a even better perspective with regard to signal processing, this shear mapping can be any different, can be any process that gives us a change. So let's consider I have my initial data, right? Let's consider a neural network, okay, a convolution neural network. I have my initial data, then I do some processing onto it, right? And I get my feature map out of it. Okay, so when I take the feature map, I take the eigenvalues of the feature map, it tells a different perspective. We'll be able to identify what the variation I did or what the convolution operation has brought onto my feature map, right? So that shear mapping can be any particular system of equation that brings a change in a given data. I already have a system of equation A, and this shear mapping represents the vector x. So that is ax is equal to lambda x, correct? So A is my system of equation. I'm multiplying my system, allowing my system to be exposed to some external pressure called x, but to some external variation called x. So this x can be a vector, this x can be a matrix. So as we all know, any real-time operation we represent it mathematically in terms of vector, right? When it is a force, we call it with a vector, or if it's any variation, we give it with a matrix, right? So when I'm getting or allowing my system to go to some variation, I call that as a shear mapping. So any particular concept that's giving a change in a variation is called the shear mapping, right? So and also like there was a question with regard to rank of the matrix. So like by literally looking of the rank of the matrix, we can tell like whether the matrix has independent rows of column or independent rows or dependent rows of column or what. So this helps us identify when we have data in a columnar manner, right? So to determine what set of features are interdependent and what set of features are not dependent or what set of features are independent, right? So in those cases we go for the rank of the matrix, right? And a rank has like numerous applications, like for example the rank of the matrix will also tell us how many how many eigenvalues we are going to get. So if a matrix has full rank, so this means like the left and right null space contains a zero vector, and it goes like so on. It's like from each application it varies like where we use the rank of the matrix. It's basically like properties. For example, to check whether we can decompose a matrix, what do? We first check if the matrix is stable, that is it should not the determinant value should not vanish, right? So similarly we use the rank value for different testing purposes. For example, when the matrix is having a full rank, I'm having a 3 cross 3 matrix and my rank is also 3. In that case we tell that the given matrix will always be is also a square and invertible. So we use this rank based applications to as a checkpoint. As we've discussed, we have different checkpoints, right? So this rank can also be the kind of checkpoints for while implementing our machine learning algorithm. Okay, so any other questions?
Sandhya, that
Yes.
last collab file which you have been showing related to the Google pages,
Related to, sir?
that Google page ranking, something you have been showing it, last coding part.
Yes, sir.
Yeah, that one you take it up, and if possible, you can put in explanations on that.
Is it this one, sir?
Come down. Yeah, exactly correct. Agent values, agent vectors, and that page model problem you had given. No, if possible, if
Yeah.
you put explanations how does it works about it, it will be great.
Yeah, sure. So like eigenvalue, like literally eigenvalue is present in every place. Like let's consider there was a case where a bridge collapsed in US or London, I don't remember the place. The bridge recently, some time back, the bridge actually collapsed because the proper eigenvalue was not selected for the bridge, right? So eigenvalue is present literally in every in most of the real-time applications that we do. So here using eigenvalue problem, we have a description for two problems. So one is the page rank algorithm, another one is the vibration of multi degree of freedom mass spring system, right? So first coming to the page rank. So page rank is an algorithm that's used by Google to rank the importance of a web page. Like when we do a search engine, the first page comes out, right? The first page the search order basically, right? The concept of this, so like most of us are familiar with the search engine optimization, so it's something related to that. The concept is that every web page has a importance code, and it endows its importance evenly amongst the pages to which it links. So the will lead of the problem where the ranking of all pages is an eigen problem, and we'll demonstrate the process for a small web of 4 pages. So using the eigenvalue, we are going to help us get the rank of the different pages that has to be there. So let's consider a web of 5 pages, P0 to P5, and consider the scenario that P0 links to P1, P2, P3, and P4. P1 links to P2, P3, and P4, and so on. So we can build a directed graph to describe the connections, and for this we'll use a package called NetworkX. So that's there in the link with the GitHub link here, and we're going to visualize the graph with respect to matplot. So we're basically we're trying to interpret an analysis and analyze how each page is actually rated, right? This happens, so this kind of things are basically done in every website that we do in the form of cookies, correct? So note that the edges have been given a weight in which is 1 by n, where n is the number of outgoing links from a page or node, and this is the fraction of page's importance that it can give to the pages which it links. So we are just giving a weight value which is 1 by n to the number of outgoing links. Like as we all know, when we take a page, we have number of outgoing links onto the pages, right? And each page is also monitored. We have special Google APIs itself to analyze exact locations of where our cursor points in a given page, right? So to that level, or to that much amount of data that we do. And this is a similar case where we are analyzing what's the number of clicks that has happened onto the given page. So if we denote the rank or importance of the page I by X, we can express the importance of a graph. So we are just using this formula of 1 by n, we are trying to express the importance of each page. So our ultimate or the work is basically getting the system of equations itself. So any real-time scenario we have, it's important that we map it to a system of equations. So this system of equations are then expressed using our matrix format. So our work here is like to exactly map or to get the system of equation, to derive that x naught is equal to so and so, x1 is equal to so and so. So for this we require the expertise of both the field expert as well as the data scientist to get the equations done. So because this equation is describing us the system or the problem that we are trying to solve, right? So then we are having the system of equations here expressed, and we are multiplying it with our so there's the basic explanation that we have ax is equal to b, that we've already seen in our in the previous cases, right? So this is an eigenvalue problem with lambda is equal to 1. So to solve the problem, we need to find the corresponding eigenvector. So first we can create a matrix A directly from the graph. Note that we added the weights onto the graph edges. While building the graph, as we saw previously, there were weights added onto the graph, and we get the matrix containing the graph weight, and we provide the node list. So this is about getting the node list and the rows and columns of the data, and the direct computation of page rank vector. So note that the columns of A sum to 1, and such a matrix is called the stochastic matrix. And in our context, what is important is that the largest eigenvalue for such matrix is 1. So therefore, we are looking for the eigenvector associated with the largest eigenvalue. Another important factor with regard to eigenvalue is always there'll be only unique eigenvalue, but there can be more than one eigenvector associated with the given eigenvalue. So generally for every eigenvector for every eigenvalue we'll have two eigenvectors associated with it. That is the right eigenvector and the other one is the left eigenvector. So most often we'll be ignoring the right eigenvector. We generally say every eigenvalue has an eigenvector, and that eigenvector is predominantly the right eigenvector. But when we have I think I can just show you here. So basically this is the equation that we generally know. Ax is equal to lambda x, where x is the eigen vector and lambda is the eigenvalue. So here in the page rank value, we saw that lambda was equal to 1. The eigenvalue was equal to 1. Generally, we say there's only one eigenvector associated with eigenvalue, but basically we have two set of eigenvectors associated with a single eigenvalue. So that's given as Ax is equal to A into xr, that's the right eigenvector, is equal to lambda r into xr, and xl A is equal to lambda l into xl, right? And so the thing here is, like, most often we go only with the right eigenvector and we don't go with the left eigenvector, and we have lot of properties related to this. It again goes as it's like a chain of properties with regard to Hermitian matrix, covariance matrix, and so on. Correct. So coming back here, so when a matrix that has the columns of A sum to 1, we call it to be a stochastic matrix. And in our context, it is important that the eigenvalue of for such matrix is 1. And therefore, we are looking out for the eigenvector that's associated with the largest eigenvalue. So it's important that we identify eigenvector that has the largest eigenvalue, because it's going to be the most important feature, and that particular vector do not undergo any variation when there was a external force happening on it. So when it has not gone any variation, this means that it has the strongest property that is holding the system of equations. So basically it's like we are trying to identify what is the what is one particular direction that holds the maximum property of the system, because we're going to teach the algorithm to learn, right? The machine has to learn ultimately. It has to identify some hidden patterns onto the data. So this eigenvalue is helping us identify that hidden patterns present inside the data. So when we take the largest eigenvalue, if you can recall the figure that we saw, there was one red color bottom line and there was one blue color tilted line. So the red color bottom line did not vary. Maybe there's another eigenvector also, right, that did not undergo any variation, but we always opt for the eigenvector with the largest eigenvalue, because that particular vector had allowed itself for a variation to happen from externally, that it has allowed itself for such elongation or for such contraction, but it did not vary its direction. So that's the key point. So that's the reason why we always look out for an eigenvector that's associated with the largest eigenvalue. And we go for the direct computation of page rank vector. To find the solution, we compute the eigenvector of A and pick the eigenvector that corresponds to lambda is equal to 1. So that goes with the implementation of eigenvalues and eigenvector. And the page rank vector has been normalized using L1 norm. And norm, yeah, sorry, I did not actually touch up with norm. So all of us are familiar with norm. Like we have heard this somewhere or the other, L1 norm, L2 norm. But this L1, L2 norm can do huge amount of, it can be of lot of benefit when we properly utilize into our data. It has lot of mathematical interpretation to give us with regard to the data and to inculcate into the data. So we'll have a in-depth view of what this L1 and L2 norm does in the day after tomorrow sessions. How kind of regularization can be done with L1 norm, regularization with L2 norm, what happens when we are varying the weight value with respect to L1 norm, and how this L1 norm is affecting our weight update with regard to gradient descent applications. Like as we all know, we use this L1 norm for regularizing, right? We add the penalty factor to get the regularization done. So in our forthcoming sessions, we'll see how L1 norm and L2 norm helps us in bringing out this regularization value. Right, and following this we go with approximation of page vector rank by a power iteration. So the direct computation of all eigenvalue and eigenvector is an expensive operation and can only be reasonably performed for small matrices. However, we are interested in eigenvector corresponding to the largest eigenvalue. So recall that in most of the cases, the repeated multiplication of eigenvector by a matrix A will yield a vector that tends to the direction of eigenvector corresponding to the largest eigenvalue. So we can use this approximate page rank vector using only a matrix vector multiplication, right? So they've just given a justification of why we go only for the matrix vector kind of multiplication. So from this we see that the estimated page rank after iteration is of all the pages that we have, p1, p2, p3, p4. So this is the kind of ranking that we get, and after 10 iterations, so this is the kind of ranking we get. So basically this eigenvector and eigenvalue, as we saw, it is helping us give us the most important feature or the most rich feature from a given set of data. So when we are just arranging them in a descending order, the first value will always be the vector that has the highest potential information. That's what PCA is all about. So we'll see how PCA does this in our dimensionality reduction sections, right? So then going with multiple degree of freedom.
Sandhya, 1 second.
Yes, sir.
Before getting to the next topic, there is a question that is data science only meant for decision making? Can it be used for device development?
Yeah. Is data science only meant for decision making? Can it be used for device development? So device development in the sense, like, what do you mean, sir?
That is just being put by a
Okay,
device,
product.
maybe.
Yeah. So device development in the sense, like, could you please elaborate on the question? Product development. Yeah. Data science is. Yes, we basically.
Product. Yes, put it as a product.
Yeah, so can it be used for product development? We use different insights obtained from our data science for the product development itself, right? So like basically, if you look around, every product has some kind of data science into it. We all use fingerprint sensors, so that's data science, right? So we all use a face unlock, so that's again a data science. So it's meant with the decision making, and also these algorithms go into are directly deployed onto the device as such. Rather than saying can it be used, yes, it is used for device development and manufacturing kind of industries, and in a even wider perspective, it directly gets deployed onto the device itself, right? We all have Fitbit watch, right? Though it has some pressure sensors into it, so it gets the data from the from our body, and it does some processing in our in the phones. So similarly it goes, so it's deployed onto the device, and it's also used in manufacturing with regard to device development. So yes, we'll be covering hypothesis, inference, and optimization part. We'll be having all the optimization with regard to SVM, and the session of SVM we'll be getting this. I'll be sharing all the codes, the ODE codes with SymPy to sir, help in improving the models. Yes, we'll talk about regularization part. We'll talk about optimization, underfitting and overfitting problems. We'll be having a in-depth explanation of that too. Right. So, any more queries?
Yeah, you can go with that last model which you have been trying to explain.
So,
Yeah.
before I just go, like there was a question with related to multicollinearity before along with yeah. So multicollinearity is basically like it's just telling us that two or more features are more related, two or more features are more related, and this multicollinearity basically comes into picture when we go for regression, the polynomial regression, or when we have a multiple regression, right? And so in that case, like that's where collinearity comes. So multicollinearity occurs when two or more independent variables are highly correlated with one another in a regression model, basically. So on a definition perspective, it happens when two or more independent variables are very much highly correlated, right, with regard to our regression tasks. That's basically about multicollinearity.
Cynthia, the last part you can explain it, and I think within next.
Yeah, yes, I'm just sharing my screen. So yeah, so with regard to multiple degree of freedom, so the degree of freedom is again a very important concept with regard to mechanical. So we've all studied this somewhere in physics or in our 11th grade. So it's again important parameter or metric with regard to mechanical systems and machines. So eigenvalues and eigenvectors are used to understand the dynamic response of a mass spring system. So when I'm having a mass and I'm having a spring, right? So eigenvalues and eigenvector is helping us understand the dynamic response of it. So let's consider a system of equations. The system of motion of multiple degree freedom mass spring is here. So and the displacement of the masses is given here. So displacement where we're bringing a small change onto a given mass. So for the problem in lecture with two mass of equal mass connected, for the problem in the lecture with two masses, so we're having two mass, two weight bodies connected to spring. So they're just hanging from somewhere of equal stiffness. The mass m is given as so this is the movement of the mass, and the stiffness k is given as, the mass is given as this, and the stiffness k is given as this, right? So eigen, like the a real-time application of this is with regard to our bridges. So we have all have a lot of bridges in our cities, right? So there's sometimes a hanging bridge and all, right? So there it's very important that this eigenvalue has to be maintained. A real-time example is a bridge itself collapsed, as I told you, because the engineers had opted for a wrong eigenvalue. So to that level, eigenvalue is very important in a it plays such an important role in a day-to-day life. So eigenvalue and eigenvectors. So we now take a brief excursion to the properties of eigenvectors related to the matrices K and M. But the purpose will soon be clear, and consider the eigenpair for the generalized problem. So this is the kind of pair that we are mapping, where lambda is the eigenvalue and u is the eigenvector. The orthogonality of eigenvector, we're multiplying both the sides with the equation with the corresponding u transpose of j. And since the eigenvectors are orthogonal with respect to k and m, and if they were normalized such that u transpose mui is equal to 1, it follows that u transpose mui. So this is the kind of equation that we give. This is with regard to the the mechanical perspective. So as we saw the previous session, both this machine learning goes hand in hand with the domain based application as well as the as well as the machine learning perspective. So when we go to the mechanical, some person as a mechanical engineer should be there, another person as a machine learning engineer should be there. So the knowledge of both the people is required for us to get a better system, better model that's predicting and classifying. Right. So decoupling the modes. So since the eigenvector are linearly independent, we can use them as a basis to express our displacement vector. So they are using the eigenvectors to express the displacement vector. That is how much my weight body has moved. Where lambda are unknowns, and taking the derivative with respect to the time, we get a certain equation, and inserting these expressions. So we get the equation as m into summation lambda ui plus k into summation lambda ui is equal to 0, and multiplying on both sides with respect to u, the equation varies as so. So from the orthogonal properties of the eigenvector, for the case I is not equal to j, the above becomes a trivial. 0 is equal to 0. When I is equal to j, we get a ordinary differential equation. So for every I, and this is a second order constant coefficient equation, which is easy to solve, right, as we all know. And we get the roots of the equation, and this is the displacement vector, where lambda is the natural frequency and ui is the vibration mode. And the constant ai and bi are determined from the initial conditions. So for a 2 cross 2 system, to get a complete solution, we are obtaining the solution based on it, and we compute the eigenvector and eigenvalue of the generalized problem for k and m. So from this we obtain the value of x, so the motion of the mass, that is a displacement x. And so from here we see the motion of the initial conditions has been obtained, and we compute the b1 and b2 using the numpy. And animating the motion of mass, for this case we just use a matplot to see how the string is actually moving here and there, right? So what do we tell from this? So what do we infer from this is that the eigenvalue and the eigenvector will be helping us to identify the degree of freedom and helping us select the direction with regard to vibration of the body, and also with regard to the motion of the body, right? Like mapping it with respect to the previous example that we saw, bridge. So when it is a hanging, with how much vibration intensity it can withstand. So this is the kind of applications that eigenvalue is used in the real time. Right. So any doubts?
Sanjay, is it possible to run that animation?
So yes, sir. So actually, it was like a very short duration, so like
That's
so
right.
that's the reason.
Oh,
It
next two, 3 sessions when you're having it, we'll make it out accordingly, please. No problem.
yeah, sure. Participants, sorry for the inconvenience caused.
Please come. Last part of animation.
Yes. So like basically, when we run from the first, only the last one comes.
Yeah.
I'll just directly try playing it.
Yeah, I think it will play.
No. Yeah. So it's telling us we are having two bodies, and the two bodies are moving 1 and 4th. So we are using eigenvectors and eigenvalue. We are determining what is the kind of movement, or in what are the directions this two body will move when it is given an external force. So using this, we'll be able to determine what is the way in which the body will move, or what is the or how far the body will move. So when we are getting the eigenvalue, so let us consider a hanging bridge. So when it's given to an external force, using when we can identify how far the hanging bridge will go when we are able to identify the eigenvector with a maximum eigenvalue, because eigenvector with a maximum eigenvalue will tell us how far the system has elongated, how far the system has moved. So here, when we are getting the corresponding eigenvector with the highest eigenvalue, we can determine how far the mass bodies has moved. So we are basically hanging a two mass body using a string, right? So getting the eigenvalue of the getting the largest eigenvalue of the eigenvector will tell us how far the string body actually moved from our initial position. So let's like considering for bridge, so how far the bridge actually moves when we are putting it to an external pressure. So like this is a kind of interpretation of how it basically happens.
Sandhya, we'll go for a question session if there is any questions.
Yeah, so sure. Any queries?
So, Sandhya, we thank you for your last minute way of helping us in coming over to mathematics in data science. Whereas I think the participants should have got benefited and overall glance of how the mathematics could be applied in data science. And that's the way it had happened now. So we thank Sandhya for taking up an efforts, being with us for last 2 sessions. However, she is having 2 or 3 more sessions over the next, where she'll be talking more about neural networks, convolutional neural networks, which was her specialization, in which she done some more products based on that. On the last day session, she'll be showing a demo product, which was being winning a prize over there in Canada for its exhibition. So she'll be sharing some more projects and other things over there. So we thank her for her being with us, and we thank all the participants, and we all meet again for statistics in data science, which will be covering a basic statistics and the programming part of the statistics in Python. That will be at 2:30 from 2 to 4. So thank you all participants. We'll come back again by 2:30. Thank you all.
Thank you, sir. Thank you. Thank you, everyone.